Uh, right. I think all good. So, good evening, everyone. So, now today also we are streaming the class via YouTube. I think next week onwards we are streaming back through Zoom. Give some replies via the YouTube chat. All good. If you all can hear me speaking, give some replies to the chat. Reply everyone. If you all can hear me speaking and all good, use some replies. Put some replies. Put some replies. All good. Right. Okay. So now give some replies like that. Okay, now whenever you have doubts also, just because others are able to see your problem, your question, you don't avoid asking questions. Always ask questions only for today. First week will only for this month. Most probably next month, the first week I will stream via YouTube as well as Zoom from next month. Right, today only we are streaming via the YouTube. The next week onwards, as usual, we are going with the Zoom, right? If you have any doubt, you ask the doubt, right? And also, please keep a communication because, right, because if you don't reply in the chat, sometimes I can't see whether there is a contact between you and me. I can't see. Therefore, if you have doubts, you please ask, please put in the message, respond what I'm asking, right? Respond what I'm asking. Okay, right. Okay. Okay, one last time. Once again, everyone, give me a small response. All good. Give me a small response, everyone. All good. All good. Okay. All good. Today we are doing. I think we supposed to start unit 2 hydrostatics theories today. I will try my best to start hydrostatics theories today, but I'm mainly focusing the last pending section in force equilibrium. And today, entire time, I might dedicate to do questions in force equilibrium. But for sure, the tutes, the February month's tutes, I think you are getting unit 2 hydrostatics and fluid dynamics tute and unit 3 optics tute and also unit 2 practical tute. So you will get 3 tutes will be posted most probably next week. So by the before next week Thursday, you will get those 3 tutes also. That story. Okay, today our ultimate goal is we are discussing more tute questions and we are going to tara these force equilibrium sections. Therefore, stay focused. So we are taking the first break around 6:45. Then again, we are doing the class till 9:15. Today we are doing the class overall till 10:30 maximum. 10:30 maximum. Okay. So if you have doubt, ask that story. If you have doubt, ask. Okay. Now go to the tute. Go to the tute. We have small theory section to be done. Uh, First of all, we'll do some questions and we'll come back to the theories. Take your tute. Take your tute. Take your tute. Take your tute, everyone. I shared the PDF version of the tute also in the groups. If anyone does not have the tute, they can refer the PDF. Take your tute, everyone. Take your tute, everyone. All right. Okay. Now in the tute, page number. Right. Page number 47, question number 18. Page number 47, question number 18. Start with that question. Now we talked about force equilibrium. Right, when I do the question also, I will revise the things that we learned under this section. Start from this questions, page number 47, question number 18. Only do under 18, only do part 1 and part 3. Page number 47. Start doing question number 18, everyone. Question number 18. Only do first part and third part. First one and third part. There are 3 diagrams they have given. 3 diagrams. Do the question, first diagram and third diagram. Start doing. Start doing. Then after that we'll discuss 21, 22, then 23, 25. 21, question number 22, then question number 23, question number 25. Start doing. Start doing. Start doing. And 15. 15. 15. Right? 15. Okay. Just keep it right. Okay. Question number 18, story. Question number 18, idea. 18, idea. Right. Find the tension force in each string in the below system. Right. 18, first diagram. Draw the diagram first. Everyone start drawing the diagram first. Start drawing. And can someone put a WhatsApp message under that questions related to moment of force and force equilibrium? What are the questions we discussed already in our theory class? Can someone put a message WhatsApp? Question numbers we discussed already. Can someone put a WhatsApp message? Put a small message. Everyone? Put a small message. Start doing these questions. Today we are doing the class till 10:30. Sometimes based on my mood, sometimes I will do the class till 11. Not sure. 10:30 is our margin. (10:30). (10:30) is our margin. Quickly start doing, don't waste your time. Parallelly, I want someone to send the question numbers. Already I discussed in the class via WhatsApp. Via WhatsApp. Quickly. Quickly. So we did only 2 sample questions, didn't do any tute questions. We discussed question number 3 only. Only we discussed question number 3. Alright, question number 3. Okay, fine, right, okay, fine. Okay, fine, it's okay. Today we are doing the questions. Start with these questions. Find the tension force in each string in the below system. Okay, right. I'll guide you. First of all, everyone draw a larger diagram in your book. Don't draw small diagrams. And use pen, but especially use rulers. Don't use pencil to draw the diagrams. Use pen to draw the diagrams, but use rulers. When it's needed, use rulers. Okay. Question number 18, idea. Every question learn something. Theory finished. Learn something from every question. Question number 18. Question number 18, there are 3 strings. Okay, stay focused until the first break. Stay focused, right? Don't do anything during your studying. Stay focused and get the maximum benefit from a session. Don't waste your time. Okay. Right. Okay. Start draw the diagram. Right, okay. Now we want to find the tension force in each string in the below system. We can see that they have marked T1, T2, T3. Now there are three strings. String 1, string 2, string 3. Okay. This mass is given how much? The mass is how much? Mass 10 kilogram. Mass 10 kilogram. 10 kilograms. So now we can mark the forces on 10 kilogram, and also if it is necessary, we can mark the tension forces also. Right? I take this point as point capital O. Point capital O. This point is point capital A, point capital B, point capital B. Right? Now given data, mass of this object is 10 kilogram, given data. What is given data? What is given data? They mentioned this angle is 6 degree. This angle is 6 degree. Given data. Also they mentioned this angle is 90 degree. Then O-level maths we all know that it's a right angle triangle. Right angle triangle. This angle 60 degree means what must this angle? This angle must be 30 degree. 60, 30, 90. 60, 30, 90. Now first you want to understand this 10 kilogram as well as entire system is under equilibrium. Clearly? If the 10 kilogram meant all the points on the strings also under equilibrium. Then we learned if an object is under equilibrium, that object, it can be an object. If they mentioned a system is under equilibrium, now this system is under equilibrium. Then you can consider all the objects in the system. If not, you can consider any point on the system. Right? Sometimes your points can be this point capital O, point capital A, point capital B. It can be any point or any object in your system is under equilibrium. Then we learn two conditions. Then there's a resultant, if that object is under equilibrium, the first condition is resultant force must be 0. The second condition is the resultant torque acting on the object, acting on the system at any point must be 0. So we know that if an object is under equilibrium, we learned resultant force of the system is 0. The second condition also we know that resultant torque at any point on the system is 0. These are the two conditions we learned. Right, first of all, we'll go with option 1, resultant force of the system is 0. Now, that means this 10 kilogram is also under equilibrium. What can you say about point capital O? Point capital O also should be at the equilibrium. Point capital B, any point on the string, any point on this string, all the points, all the objects must be under equilibrium. Then sir, 10 kilogram is under equilibrium. Also, point capital O is also under equilibrium. First of all, shall we mark the force on 10 kilogram? If I mark the forces on 10 kilogram, the weight force mg, 10 into 10, 100 Newton, the weight force acting downwards. The weight force acting downwards. That is 100 Newton. What is the other force acting on this 10 kilogram? The tension force. The tension force acting on 10 kilogram is what? Capital T2 upwards. Tension force capital T2 upwards. I told you when you're marking tension force acting on the object is always away from the object along the string. Tension force on 10 kilogram, capital T2 upwards. Then there are only two forces acting on 10 kilogram, capital T2, 100. Then if I consider equilibrium of 10 kilogram, learn from questions. You can write down equilibrium of 10 kilogram. What can you say about resultant force acting on 10 kilogram? Must be 0. Resultant force of 10 kilogram must be 0. You can say the resultant force must be 0. Therefore, upward force must be equal to downward force. T2 equals 100 Newton. You can write like that. When you consider equilibrium of 10 kilogram, resultant force must be 0. That means T2 upward must be equal to 100 downwards. So you can write down, you can directly write down equilibrium of 10 kilogram, T2 must be equal to 100. But if you are following the steps, we can write down resultant force must be 0, upward force is positive, downward force is negative. Therefore, upward T2 plus T2 plus T2, downward force minus 100 must be equal to 0. Minus 100 right side. Then the tension force, capital T2 must be equal to 100 Newton. Right? These are different ways of getting the answer. But anyone understands, now, do we want to follow these 3 steps? Can't we directly write down? Because there is only 2 forces, upward T2 and downward 100 Newton on 10 kilogram. So therefore, I can write down T2 must be equal to 100, right? You can write down. But if I'm following all steps, this is how I want to do the question. This is how I want to do the question. Right? If you have doubts, keep on asking. Don't waste your time. Then okay. So now I found T2 is 100 Newton. Tension force along this string is how much? 100 Newton. But I want to find tension force along this string, tension force on this string. How can I find that? I consider 10 kilogram mass equilibrium and I found T2. I told you, not all 10 kilogram mass, but also you can consider any point in the system under equilibrium. If I consider point O is a point, right? If I consider the equilibrium of point O, shall we mark the forces acting at point O? Because of this string, what is the tension force acting on point O? Downwards T2. We know that tension force always away from the object or the point that you are considering, away from the object or the point that you are considering along the string. Tension force, if I mark tension force at point capital O, on point capital O, that is downward capital T2. Right? So we know T2 must be equal to 100. That story we know. Okay, historically, if you have doubt, put the doubts in your chat. Don't keep doubts. T2 we know 100. When you consider this string, tension force on point capital O due to this string, that is what? That is what? That is capital T1 along string away from point 2. This tension force capital T1. Capital T1. I want to find T1 also. And if I mark tension force on point capital O due to this string, along the string away from point capital O, away from point capital O, therefore tension force going to be capital T3, this direction. When I consider forces on point capital O, there are 3 forces, T1, T2, T3. T1, T2, T3. This point capital O also under equilibrium. Point capital O also under equilibrium. Now, tell me what can you say about this angle? This angle? This angle 60 degree, right? It creates a right angle triangle. This creates a right angle triangle. Then what can you say about this angle? This angle going to be how much? It's going to be 30 degree. Am I correct? Can someone tell me what should be this angle? What should be this angle? This angle is 9 degree. This angle 30 means this angle must be 6 degree, 60. If not, when you can take like this also. If you take this right angle triangle, it's 90, 30, this angle must be 60. If not, this angle is 90 means, this angle 30 means, this angle must be 60. Right? Likewise, small story. Put some replies in the chat. Anyone finished finding the answer of this question? Today we are doing story only, finished. Today I will start hydrostatics. If not, right? Finish, put some replies. I got the answer for T1, T3. T2 I found 100. And put some replies. I got answer for T1, T3. Everyone? Got the answer for T1, T3. Put reply everyone. Got the answers. Keep on doing. You have lots of questions. Got the answer, put some replies. If you got the answer, put some replies. Right? If you got the answer, put some replies. Put some replies. If you got the answer, put some replies in the Zoom chat, YouTube chat. Put some replies. Put some replies. Okay? Now consider the equilibrium of point capital O. If you consider equilibrium of point capital O, you can easily find T1, T3. How? How can you do that? Right, if you feel like I can draw these three forces separately and I can show you the idea. Right, if not, we can get the idea this way also. Right, okay. I will do this part separately. Look here. So we have T1, T3 and T2 is how much? T2 on point capital O. If I consider point capital O, I want to find this tension force. I want to find T3. This angle is 60. And then I want to find T1. I want to find T1. This angle is 30. T2, I know that. Tension force T2 is how much? That is 100 Newton. T2 is 100 Newton. This is how much? 100 Newton. So then do the vector resolution. There are different ways to get the answer to the vector resolution. I advise to resolve T1, T3 into vertical and horizontal components. Then what is the vertical component of T1? T1 cos 30 upwards. Vertical component of T1 is what? T1 cos 30 upwards. T1 cos 30 upwards, vertical component of T1. Get the answer. Get the answer. What is the vertical component of T1? T1 cos 30. Get the answer. Get the answer. Keep on doing. Find T1, T3. Find T1, T3. Quickly. Keep on doing. Have lots to ask. Keep on doing. Vertical component of T1 is what? T1 cos 30 upwards. Get the answer. Okay. Vertical component is what? T1 cos 30. T1 cos 30. What is the horizontal component of T1? T1 sin 30 left side. T1 sin 30 is the horizontal component of T1, T1 sin 30. Likewise, resolve T3. What is the vertical component of T3? T3 cos 60 upwards. T3 cos 60 upwards. What is the horizontal component of T3? Right side. Ni? T3 cos 60 upwards. T3 sin 60 right side. T3 sin 60 right side. This story we know. And now simple. Right? Earlier there were three forces, T1, T3 inclined forces. And T2 is 100 vertical one. You resolve this T1, T3 into two perpendicular components, vertical and horizontal. Now how many vertical forces are now? Now there is T1 cos 30 upward, T3 cos 60 upward and 100 downwards. There are three vertical force of force components. How many horizontal force of force components? T1 sine 30 left side, T3 sine 60 right side. Point capital O is also under equilibrium. If point capital O is under equilibrium, resultant vertical force must be 0. What is the meaning of that? On point capital O, vertical upward forces must be equal to vertical downward forces. Right? And also, resultant horizontal force on point capital O must be 0. What is the meaning? All the horizontal forces must be, all the right side force must be equal to left side forces. Very simple story. Now can I get the answer? If I consider vertical equilibrium, look here. If I consider horizontal equilibrium, considering the equilibrium of point capital O. If you consider equilibrium of point capital O, right? So then also we can write down resultant force acting on point capital O must be 0. That means what? That means we know resultant vertical force must be 0. Resultant horizontal force must be 0. Right? That means we know resultant horizontal force must be 0. That means what? Horizontal right side force must be equal to horizontal left side force. So one can write down T3 sine 60 equals T1 sine 30. One can write down T3 sine 60 equals T1 sine 30. If not, I can write down T3 sine 60 minus T1 sine 30 equals 0. Right side will be positive. In that case, T3 sine 60. Right? First question seems like difficult, but get the idea. T3 sine 60. T3 sine 60, right side force. Left side force is what? T1 sine 30 left side. Left side will be minus T1 sine 30. T1 sine 30 must be equal to 0. Minus T1 sine 30, if you move to the right side, it's T1 sine 30. So T3 sine 60, T3 sine 60 must be equal to how much? Right side, T1 sine 30. T1 sine 30. Okay? Now this is not the big deal. Very simple. If you consider the horizontal equilibrium of point capital O, right side force T3 sine 60, left side force T1 sine 30, they are equal. Right? But I'm following all steps. Put some reply. Anyone finished finding T1, T3? If you finished, put some reply. Put some reply, everyone. If you finish finding T1, T3, put some reply. In the YouTube chat, put some reply, everyone. Put some reply. Finished? Put some reply. Put some reply, everyone. Quickly. Put some reply. Put some reply, everyone. If you finish finding the answers for T1, T3, put some replies. Put some replies. Put some reply. Put some reply. Put some reply. Many done. Done. Keep on doing. 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 Please, everyone, if you finish doing this question number 18, first part, this question, put some reply, done, done, done. Question number 18, done. Put some reply like that, okay? Because we can't see anything properly. Put some reply, question number 18, done, done, done. Something like that, put everyone, if you finished. While others try the remaining questions. Then sir, I can simplify further. I want to find T3, T1. There are two unknowns in one equation. Therefore, I want another equation also, right? First of all, I will simplify this further. Sine 60 means root 3 over 2. T3. Sine 60 means root 3 over 2. Root 3 over 2 must be equal to T1. Sine 30 means half. Sine 30 means half into half. Then this 2 cancel out. I can write down T1 is what? T1 means root 3 T3. Finally, I can write down T1 equals root 3 capital T3, equation 1. Equation 1. Equation 1. My target is finding T1, T3. I found T2, 100. Then T1 equals root 3 T2 when I consider horizontal equilibrium of point capital O. If you consider vertical equilibrium of point capital O, there are three vertical forces, T1 cos 60 upwards, T3 cos 60, T1 cos 30 upwards, T3 cos 60 upwards, 100 downwards. Now consider vertical equilibrium resultant. We know resultant. Vertical force must be 0. Vertical upward force are positive. Vertical downward force are negative. Think like that. Then you can write the story. You can write down T1 cos 30. Okay. T1 cos 30. Upwardly positive. T3 cos 60. That is also upwards positive. T3 cos 60 upwards positive. This must be equal to what? Downward force, that is 100. Downward force 100. 100. Now simplification. 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 Get the answer. Get the answer. Get the answer. Simplification. Cos 30 means root 3 over 2. Now T1 means we all know that from equation 1, T1 means root 3 T3. From equation 1, we know T1 means what? Root 3 T3. Substitute. T1 means root 3 T3. And also cos 30 means what? Cos 30 means root 3 over 2. Root 3 over 2 plus T3 cos 60 means half. T3 cos 60 means half. Must be equal to 100. Simplification. Simplification, root 3 into root 3 is just 3. So 3 over 2 capital T2. 3 over 2 capital T3 plus what? Half T3 plus half T3 must be equal to 100. Must be equal to 100. Now you can take T3 as your common factor out. I am following all steps. You can quickly finish the steps and you can quickly get the answer by avoiding some unnecessary steps, but I am following all steps. Then T3 if I take as common factor out, 3 over 2 plus 1 over 3. 3 over 2 plus 1 over 2. 3 over 2 plus 1 over 2. Must be equal to 100. 100. Then common denominator is 2. 3 plus 1. 4 over 2. 3 plus 1 is 4. 4 over 2 is how much? That's 2. Then my T3 is going to be how much? 50. Finally here T3 into 3 plus 1 is 4. 4 over 2. T3 into 4 over 2. 4 over 2 must be equal to how much? That is 100. When you substitute T3, now you can divide 2 by 2. Here 4 by again 2. It's 2. If you substitute T3, 100 over 2 is 50 Newton. T3 is 50 Newtons. T3 equals to 50 Newtons. Then what can you say about your T2 value then? T1 value. If my T3 is 50 Newton, from equation 1, T1 means root 3 into T3. T3 50. Then I can find T1 also, root 3 into 50. So from equation 1 I can write down, from equation 1 therefore, what is my T1 value? My T1 value must be how much? That is root 3 into T3 is 50. Therefore T1 is how much exactly? 50 root 3 Newton. Right? T1. Put some reply. How many of you got these answers? T1 to T3. Now in this question we considered equilibrium of point capital O. It's very important story. And then we considered equilibrium of 10 kilogram. First we considered equilibrium of 10 kilogram and we found T2. Why? On the 10 kilogram mass there were only two forces, T2 and 100. Then I found T2. Then I considered equilibrium of point capital O. Right? Then there are three forces acting on point capital O, T1, T2, T3. I considered vertical equilibrium. I considered horizontal equilibrium. Resultant force must be 0 story. I applied and I got the answer. Reply everyone, all clear that question number 18. First one is all clear. Put some reply. Put some reply. Question number 18, stories, all clear. Put some reply. Put some reply. Reply everyone. In this idea is clear, everyone, put some reply. Put some reply, everyone. All clear. All clear? Simple. Likewise, if you have doubts, you ask. Parallel, we'll go to the next part. Question number 18, the next part. Third one. Starting third one. Some questions I just give a long explanation. Start with the next one. Next story, start doing. Don't waste your time. Keep on doing. Today it's all about doing questions only. Today we are doing questions only. Start doing next one. Start doing next story. Next story. Then question number 18, next story. Keep on doing the questions. Don't waste your time. Next story. Okay. Then again the same story. Pretty much similar to this diagram, but somewhat different also. Right? Again, I want to find T1, T2. Again, I want to find T1 tension forces on the strings. Okay. Draw the diagram, third one. Third one. If you understood this idea, you can do hereafter all the questions. Keep on trying. Keep on trying. Keep on trying. Okay? Keep on doing. Get the answers. Get the answer. Keep on doing. Don't waste your time. Keep on doing. Get the answer. Others keep on doing 21, 22, 23, 25, 50. Right? Your ultimate goal is before sir get the answer, somehow I will get the answer. That's your good motive. So work in that motive. There's a vertical wall. There's a vertical wall. Now there are three strings. This point is point capital O. This point is point capital O. Okay? And what? And 10 kilogram mass is attached to this string. Okay. 10 kilogram mass attached to this string. 10 kilogram. So then again what you do, mark the forces on 10 kilogram, and you might have to mark the force on point capital O also. Right? Now they have given this angle is 45 degree. This angle 45 degree. This angle 45 degree given data. Now this angle 45 degree means if I draw a vertical line, right? This angle also must be 45 degree. Why? 45 degree, you can think in different ways. When you consider Z angle also 45, 45. If not, when you consider this right angle triangle. If you consider this right angle triangle also, 45 degree, 90 degree, this angle must be 45 degree. Right? This angle must be 45 degree. This angle is a 45 degree story. Okay. Right. Then if I mark tension force on point capital O. Due to the string, tension force on point capital O is T1, this direction. T1. Due to this string, tension force on point capital O is T2, this direction, right side. Because we know tension forces acting on a point O object is always away from the point O object along strings. This T2 is away from point capital O. T1 is away from point capital O along strings. If I mark the tension force on point capital O due to this string, that is T3. This T3 is tension force acting on point capital O. Then I can mark T3. What is this T3? Tension force acting on 10 kilogram. Then what is the other force acting on 10 kilogram? T3, and the weight is 100 Newton. If the entire system is under equilibrium, 10 kilogram and point capital O both under equilibrium. Right, then you can get the answer. Or you can get the answer. Get the answer. Get the answer. So I can consider vertical equilibrium of 10 kilogram. I can consider vertical equilibrium of 10 kilogram. I can consider, right, equilibrium of 10 kilogram. Equilibrium of 10 kilograms. Then I can write what? Then I can write down T3, resultant force acting on 10 kilogram must be 0. Therefore, upward force must be equal to downward force. T3 must be equal to 100 Newton. I can follow these things so like this also. I can write down resultant force equals 0, then T3 upward minus 100 downwards, up plus T3 minus 100 equals 0. Finally, T3 equals 100 something. But anyone can understand upward force must be equal to downward force. Therefore, just write down this time T3 equals 100. T3 must be equal to 100 Newton. Then I'm going to consider equilibrium of point capital law. Resolve this inclined force into two perpendicular components. One is horizontal component, other one is vertical component, inclined. Quickly. People who got this answer for T1, T2 got the answers, put some replies because I don't know the count. Now I can't check how many are done. Normally what we do, if many finished, I ask you to raise your hands. Based on the count, I will do the remaining stories. But since I can't see the count now, what you want to do is, once you finish, you want to put some done. Don't put just done, just put that question number 18, third part is done. Likewise, put some replies. Put some replies like that. Got the same answer for T1, substituted root 3, 1.732, got 86.64 T1. Right? What's the Q sirs doing now? Question number 18. Page number 47, question number 18, third part. People who finished, put some replies, done, done, done. Keep on doing. Okay, time is 6:45. Time is 6:45. Normally I give a break, right? 6:45, come at 6:55. Take your break, come at 6:55 and come. Take your break, come at 6:55 and come. Take your break and come at 6:55. Take your break and come at 6:55. Take your break. Today we are doing the class till maybe 11 sometimes. All right, ne? Okay, right. So we'll discuss the story now. Okay, now I consider the equilibrium of 10 kilogram mass. T3 must be equal to 100 Newton. That story finished. Now I will consider equilibrium of point capital O. In that case, shall I resolve this T1, tension force acting on point capital O into two perpendicular components? What is the horizontal component of T1? T1 cos 45. Sorry. What is the vertical component of T1? T1 cos 45 upwards. Vertical component of T1 is what? T1 cos 45 upwards. T1 cos 45 upward direction. What is the horizontal component of T1? T1 sin 45 left side. T1 sin 45 left side. Right. Okay. Then we can see how many horizontal forces or force components. T2 horizontal right side. T1 sin 45 horizontal left side. There are only two horizontal forces. How many vertical forces acting on point capital O? T1 cos 45 upwards and T3 downwards. There are two vertical forces acting on point capital O. Consider the equilibrium of point capital O, then get the answer. If you consider equilibrium of point capital O, when you consider horizontal equilibrium, of point capital O, then you can say what? T2 right side must be equal to T1 sin 45 left side. Okay, right? Okay, right. So then, okay, T2 right side must be equal to T1 sin 45 left side. I don't know T2 value. I don't know T1 value also. T2 must be equal to T1 sin 45. Must be equal to T1 sin 45. T1 sin 45. This is equation 1 something. You can simplify further, but okay, if I simplify further, sin 45 means 1 over root 2. T2 going to be how much? T2 equals to T1 1 over root 2. 1 over root 2. T1 over root 2. T2 equals T1 over root 2, equation 1. Equation 1. Likewise, now consider vertical equilibrium of point capital O. Vertical equilibrium of point capital O. The resultant vertical force acting on point capital O must be 0. That means vertical upward forces must be equal to vertical downward forces. The only vertical upward force is T1 cos 45 upward. The downward force is what? T3. Then we can say that, sir, T1 cos 45 upward. T1 cos 45 upward must be equal to T3 downwards. What is T3 value? T3 values we found it's 100 Newton. It's 100. Therefore, T1 cos 45 must be equal to 100. Cos 45 means 1 over root 2. We can easily find T1. T1 cos 45 means 1 over root 2. Cos 45 means 1 over root 2. That must be equal to 100. Subject T1. When you subject T1, T1 going to be how much? T1 going to be, if you move this root 2 to the right side, 100 Newtons. 100 root 2 Newtons. That is your T1 value. So you can simplify further and you can get the answer. But I keep the answer this level. But generally we want to keep the answer up to 2 decimals. Likewise, find, I found in T3, I found 100 Newton. T1 is 100 root 2 Newton. Now I want to find only T2. From equation 1, T2 means what? T2 means T1 over root 2. Finally, from equation 1. From equation 1, we can write down finally T2 must be equal to T1 value is 100 root 2. 100 root 2 over T1 over root 2. T1 is 100 root 2 over root 2. You are getting the answer. Root 2 root 2 cancel out. Your T2 value is also equal to 100 Newton. T2 is also 100 Newton. Simple story. That question completely discussed. Second part we'll discuss a bit later. Idea clear? Idea clear. Question number 18 done. 18 done. We'll do some, I think before doing the question number 21, based on this idea, we can practice few more questions. We'll do answer the story, clear answer, put some reply. This question is clear, put some reply. This question clear, put some reply. Question clear, put some reply. If it is clear, put some reply. If it is clear, put some reply. If it is clear, put some reply. Question is clear, put some reply. This question. Put some reply. It is clear, put some reply. Clearly? Right, okay. We'll do question number 21. We'll do 21, question number 21. Start with 21. 21 is somewhat different idea. Now, when we were doing question number 18, we only used, if an object is under equilibrium, there are two conditions happening simultaneously. Resultant force must be 0 and resultant torque acting on the object at any point must be 0. But when we were doing this question, we only used that resultant force equals 0 story and we got the answer. But there are some questions to get the answers. You may have to apply resultant force 0 concept as well as resultant torque any point 0 concept also you want to apply. Question number 21 is something like that. Question number 21, next story. 21 idea. 21 idea. Read the question. Read the question number 21. Idea. Question number 21. Read the idea. Question number 21. Read the idea. Question number 21. 21 they are asking. 21 they are saying what? 21 they are saying. 21 they are saying what? Question number 21 they are saying a uniform Planck of weight 5 capital W. 5 capital W. Right? W means a symbol. Not watts. W means symbol. Right? Weight of U is mg. Mg is W. A symbol is W. They mention uniform Planck of weight 5W. 5W and length 8 simple A is kept in horizontal equilibrium by two vertical strings. That means that horizontal rod, that horizontal Planck is under equilibrium by two vertical strings. The strings are located at distance of simple A from each end. The strings are located at distances of simple A from each end. If a load of 9 capital W is suspended from a point at a distance to simple A from one string towards the other string, calculate the tension of each string. Calculate the tension of each string. Right, okay. Now basically there's a horizontal rod and that rod is under equilibrium. There are many forces acting on the rod, but the rod is under equilibrium. So they are asking us to find the tension force capital T1 and capital T2. That's our target in terms of W's. You want to find T1, T2. If I do the diagram, this diagram, this is the horizontal Planck or horizontal rod. Okay, right. If I mark the forces acting on the rod, this rod is attached to two vertical strings, therefore tension forces acting on the rod. Tension forces acting on the rod. Okay. Tension forces acting on the rod. Right. Tension force acting on the rod due to this string is T1 upwards on the rod. Tension force T1 upwards. I want to find T1. Tension force acting on the rod due to this string is capital T2 upwards. My target is finding T1, T2. What are the other forces acting on the rod? They mention this rod is uniform rod. Weight of this rod is how much? That is 5W. Length of the rod is 8 simple A. We know that if it is a uniform rod, remember, weight of the rod is exactly acting in the middle. Weight of the rod is exactly acting in the middle. If I mark the weight of the rod, that is 5 capital W. The weight is how much? That is 5 capital W. I mark the weight somewhere here. The weight of the rod is 5 capital W. 5 capital W. What are the other forces acting on the rod? And additional load is kept on the rod, then the weight of that load is how much? That is also 9 capital W. There are 4 forces vertical acting on the rod. There are 4 vertical forces acting on the rod. The other force is 9 capital W. 9 capital W. Right. That's it. I want to find T1, T2 as my target. T1, T2. And they have given the distances. The distance to T1 tension force from the left end is simply. This gap is simply. The distance to capital T2 tension force from this end is, that is also simply. That is also simply given data. The total length of the rod is 8 simply. What is the distance? Tell me. This point, if I name some points, point capital A, B, point capital A, this is point capital A. This point is point capital A, and this point, let's take it as point capital B. Point capital B, let's name some points. Then it's a uniform rod. Weight is acting exactly in the middle. Total length of the rod is how much? 8 simply. Total length 8 simply means, tell me what is the distance to the weight, if not center point, from point capital A. So total length is 8 simply. Distance to the weight, if not center point from point capital A, is 4 simply. Here to here. Length must be 4 simply. Then what is the distance to the weight, if not center point from this point? Center point distance from point capital A is 4 simply. Center point distance from this point is what? 3 simply. Clearly, this gap is 4 simply. Then this gap is simply. This gap must be 3 simply. Clearly, 3 simply gap. Right? Then tell me total length is 8 simply. Total length 8 simply. Then what is this gap? This gap is simply 3 simply. What must be the gap between these 2 points? 3A, 4A, 5A. This is also going to be 3 simply. Simply. Right? Okay. Then distance also have an idea. Let's take some points. This point is point capital C. If you want, you can take this point as point capital D. This point you can name as point capital E. There are 4 vertical forces acting on the rod. There are 4 vertical forces acting on the rod, and very clear, rod is under equilibrium. So we can do 2 stories. The rod is under equilibrium, so resultant force on the rod must be 0. The second story is, any point on the rod resultant torque must be 0. If I apply first to resultant force acting on the rod must be 0 means all the forces are vertical only. Therefore, so vertical upward forces must be equal to vertical downward forces. Capital T1 plus T2 must be equal to 9W plus 5W. Equation 1. I want to find T1, T2 in terms of W. T1 plus T2 must be equal to 9W plus 5W, equation 1. Right? Likewise, we can do the story. If I consider vertical equilibrium, we know that. We know if I consider the equilibrium of the rod, we know that. Keep on doing. Resultant force, now learn something from every question. After doing these questions, you will get a nice idea about force equilibrium. For the rod, resultant force must be 0. Therefore, one can write down T1 plus T2 must be equal to 9W plus 5W. Directly, one can write this equation. But you don't, when I am following steps, I follow all steps. Therefore, I am following all steps. Then upward forces are positive. I take upward forces positive, downward force negative. Then upward T1 positive, upward T2 positive, T1 plus T2, downward force 9W negative, 5W negative. Then I can write down, see the idea? T1 plus T2, T1 plus T2, downward force negative minus 9W, downward force negative minus 5W must be equal to 0. If I move this negative value to the right side, T1 plus T2 going to be 9W plus 5W. You don't want to follow all steps. I obtain equation 1 is what? T1 plus T2. T1 plus T2 must be equal to what? Must be equal to 9W plus 5W. That is going to be how much? 9 plus 5 means 14W. 14W, equation 1. Equation 1. The problem is, sir, I also can obtain this equation 1 But there are two unknowns in equation 1. How am I going to find T1, T2? Because we need another equation. How are we going to obtain that another equation? So to obtain the other equation, you can apply the next story. If the object is under equilibrium, resultant torque at any point on the object is 0. So you can take the resultant torque around point capital A, you can take the resultant torque around point capital C, point capital D, point capital E, point capital F. It's up to you. It's up to you. It's up to you. It's up to you. I will show you. I think most of you are very familiar. Shall we take the result? Now, what can you say about this? If you take the result, if you take the torque around, if you take the torque around point capital A, point capital C, if you take the torque around point capital D, if you take the torque around point capital E, point capital F or point capital B, what can you say about the resultant torque around any point on the rod? 0. 0. Therefore, you can take torque around point T, if not point C. But shall I take torque around point capital C? I will tell the reason why I am selecting particularly point capital C. The reason I will tell you. Shall I take the torque around point capital C? We'll take the torque around point capital C. Start taking. Sir, if you take torque around point capital C. Okay, sir? Sir, if you take torque around point capital C. Look here. Right? Now that 9W story, wait. 9W idea. 9W. This gap is too simple, lady. Also, they have given this gap is too simple, okay? Point capital C, this gap is given as too simple, right? If I take the torque around point capital C, tell me, how many of you say that T1, I am taking torque around point capital C, how many of you say T1 produces torque around point capital C? No, 0. Since T1 passing through point capital C, T1 does not produce torque around point capital C. Clearly? Then around point capital C, 9W. 9W creates anti-clockwise torque or clockwise torque? 9W creates a clockwise torque around point C. Around, always keep your finger at point C. From the point that you're taking torque, always keep your finger. Then 9W creates a clockwise torque around point C. 5W also creates a clockwise torque around point C. 5W creates a clockwise torque around point C. So this T2 creates an anti-clockwise torque, anti-clockwise torque around point C. Even though there are 4 forces, if I take the torque around point C, only 3 forces will contribute to the torque. 9W clockwise, 5W clockwise, T2 anti-clockwise. We all know that resultant torque is 0. Next idea, look here, the way I am doing the question. If I consider the equilibrium of the rod, the second logic is what? Resultant torque at any point must be 0. Resultant torque at any point must be 0 if I take the torque around point capital C. Resultant torque around point capital C must be 0. If I take the torque around point capital C, resultant torque around point capital C must be 0. Normally I consider clockwise torques as positive. Normally I consider clockwise torques as positive and normally I consider anti-clockwise torques as negative. That's my way. You can go with your own ways. This is my way. Then sir, now, okay, we'll find the torques. 9W creates a clockwise torque around point C. Tell me the torque produced by 9W. 9W into perpendicular distance to 9W from point capital C. Too simply, clockwise torque means positive. Plus 9W into 2 simply, clockwise torque. This one is done. Next one is 5W. This one done, 5W. Around point capital C, 5W also creates a kind of clockwise torque around point capital C. 5W into 3 simply. 5W into 3 simply. Clockwise torque. Distance to point capital C from 5W is 3 simply. Clockwise torque plus 5W into 3 simply. Right? What about T2? Around point capital C. T2 creates anti-clockwise torque. Therefore minus T2 into perpendicular distance to T2 from point capital C. This gap is how much? 3 simple A. This gap is also 3 simple A. 6 simple A. Distance from point capital C to T2 is 6 simple A. T2 creates anti-clockwise torque around point capital C minus T2 into 6 simple A. Minus T2 into 6 simple A. Very simple. Really, if you learn properly, very simple. Okay, we'll take time. It's okay. Right? We can get extra time and We'll calmly will do. People, any gym, okay, any gym finished 22, 23, 25, 20, 15 answer. Answer means put some reply in the chat. Any gym finished till 15, any gym finished. Any gym finished 15 till 15, put some reply. If any gym finished that story. Okay, must be equal to 0. Must be equal to 0. Resultant torque. This is the resultant torque. Right? These three forces create torque around point C. Resultant torque is, this is the summation of this is the resultant torque. That is 0. Resultant torque is 0. This entire story is 0. Then I can find T2 easily, right? I can find T2 easily. Why? Right, move this minus T2 into 6 simply right side. Then we are getting what? 9W into 9W into 2 simply plus 5W into 3 simply must be equal to capital T2 into 6A. Capital T2 into 6A. 6A. Since there are three terms, all terms including capital W and simple A, all terms having simple A, therefore you can cut simple A, you can cancel out. 9 into 2 is 18W, 18W plus 5 into 15W must be equal to how much? 6 capital T2. 6 capital T2, get the answer. Get the answer. Get the answer, simple, not difficult. Get the answer, keep on doing, get the answer. The answer now, 18W plus 15W is how much? That is 28, 33W. Capital T2 is how much? That is 33W over 6. 33W over 6, that is how much? If you divide by 3, here it's going to be 2. If you divide by 3, it's going to be 11. 11 over 2 is how much? 5.5W. T2 is how much? T2 is equal to exactly 5.5W. Then what is your T1 value? If my T2 is 5.5W, T1 plus T2 is 14W. From my equation 1, I can write down what is my T1 value? T1 plus T2. T1 plus T2 value is, I know it's 5.5W. Plus 5.5W must be equal to how much? Must be equal to 14W. 14W, then how much? 5.5 is 6, 10, 14, 8.5W. T1 is how much? 8.4W. T1 is how much? 8.5W. 8.5W. If I am wrong, tell me, okay? Simple. Nice question. Nice question. Nice question. If you have doubts, ask. Nice question. Then we'll do question number 22. Clear, right? Clearly have doubts, ask. If you are very uncomfortable asking doubts in the YouTube chat, you can put some WhatsApp message also, I'll read. If you have doubts, put some WhatsApp message also, I'll read, okay? Okay, if you have doubts, I will put some WhatsApp messages, I will reply, okay? I'll reply. Next one idea. Question number 22. If I do that question number 22 story, same story. Question number 22, start being. Question number 22, start being. Any doubt, put WhatsApp message also, I will reply. If you have a doubt, ask. Question number 22, we are taking a break again. We'll take the break at time is 7:19. Then we are taking the break at what time? 9:15 something. So we are taking the break at 9:15. Today's question. Question number 22. Difficult questions only, but you can learn something. I'm explaining by taking the time, therefore get the maximum benefit. If you have any doubt to clarify, quickly ask your doubts and clarify it. Quickly ask your doubts and clarify it. Right? Quickly ask your doubts and clarify it. Clarify it. Clarify it. Clarify it. Next story. Question number 22. Start drawing the diagram in your book. Question number 22. 22. Start drawing the diagram. 22. Start drawing the diagram. Question number 22. Start drawing the diagram. Diagram. Now 22 idea. AB is a uniform rod of length 1.4 meter. 1.4 meter. 1.4 meter. It is hinged at point capital C. It is hinged at point capital C. I will tell you when something is hinged, what will happen. I think it's not necessary for this question. Upcoming questions, I will give you an idea. It is hinged at point capital C, which is at a distance of 0.5 meter from A, and capital B to maintain the horizontal position of the rod. Okay, right. Find the weight of the rod. Find the weight of the rod. Find the reaction force. Find the reaction by the hinge of the rod. You want to find basically capital W and capital R. In this case also, rod is under equilibrium. Rod is under equilibrium, right? Apply those two conditions. Resultant force must be 0 and try to obtain some equations. If you feel equations are not sufficient to get the answers, then apply resultant torque is 0 and get some equations. Now I forgot to tell now, see, I forgot to tell why, sir, you specifically taken resultant torque around point capital C. Why can't I take resultant torque around point capital E? So can't I take resultant torque around point capital D? So can't I take resultant torque around point capital E? You can take resultant torque around A, B, C, any point, no issue. But if you take the torque around point capital A, think in your equation, T1 also contributes to the torque. T2 also will produce a torque around point capital E. In that equation, T1 and T2 both exist in the equation. Right, can do. Then there will be two simultaneous equations and you won't simplify those simultaneous equations. But if you take the torque around point capital C, you can eliminate T1 involving in the torque equation. If not, if someone can apply torque around point capital F, you can eliminate capital T2 involving in that torque equation. That's why I taken point capital C or point capital F. If you have doubts, ask. This one. This question. This question. So next week you will get the hydraulic tubes. Huh? You will get next week for sure. And you need to practical tubes also you will get. And we have moving traveling telescope is pending. The remaining practicals I took time and nicely explained. Right? Okay. And I have done all the past papers. Just go and check all the past papers from 1992, 2025 statistic questions also I have done in the discussion. Okay. Right. Next story. This question, again, how many forces? There are 4 forces. Point capital A, point capital B, 0 point. Now there's a difference. Now there's a small difference in the questions. Now they have given length of the rod is 1.4 meter, but in the diagram it is marked as 0.5 and 0.7 meter. Right? The problem is even I also don't know what is the right value. The length is 1.40, 0.1. The length of the rod is 1.40, 1.2 meter. Even I have no idea. Right? Even I don't have the idea. What shall we do? We'll take the length of the rod as 1.2 to get the answer. Sometimes you don't get the answer given in the question. It's okay. Let's take the length of the rod as 1.2 meter and we'll do the question. Let's take the length of the rod as 1.2 meter and we'll do the question. Okay. So question number 20, yeah, I explained it. 22, they have given 1.4 meter length, but the rod's total length is 1.2. We'll take it as 1.2 meter length rod and we'll get the question. Sometimes if 1.4 is the right length, you don't get the given answers. It's okay. It's okay. Length is 1.2 meter. 1.2 meter, they have given the force, 60 Newton force acting downwards, point capital E. Point capital E, this force, 60 Newton force. Keep on doing. Keep on doing. 60 Newton acting downwards, point capital E. What is the other force acting on the rod at point capital B is 8 Newton. Point capital B, 8 Newton force is acting point capital B. 8 Newton. Right? The weight of the rod is W. This rod is not uniform. Rod is not uniform. Weight of the rod is how much? They mention uniform rod. They mention uniform rod. Look here. We'll do like this. Look here. Stop doing everyone. We'll take the length as 1.4 meter. Look here. We'll take the length of the rod as 1.4 meter. Stop doing everyone. Stop doing everyone. Weight is W. Look here. Stop doing everyone. Weight is W. I want to find W. Stop doing everyone. Listen what I'm doing. Okay. Stop doing everyone. Don't try the question. And at point capital C, the normal reaction force acting on the rod is, at point capital C, the normal reaction force acting on the rod is capital R. Actually, I want to find capital R and I want to find the W. Now, they mentioned the uniform rod and they have given distance to the weight from center of the rod to the point capital B is how much? 0.7 meter. If it is a uniform rod, this is the center point, this gap is 0.7 meter, this gap is also must be 0.7 meter. Distance from center point to point capital B and distance from center point to point capital A must be same. This gap is 0.7 meter. Stop D. Stop D. This point is 0.7 meter. Okay, there are some mistakes in the diagram. Follow my diagram. This gap is 0.7 meter. 0.7 meter. And this gap, distance from point capital A to point capital C. This gap is 0.5 meter. 0.5 meter. Okay. If this point is the center point, point capital O, center point, distance from point capital O to point capital A also must be 0.7 meter. Why? Total length of the rod is 1.4 meter. Center to the point capital B 0.7 meter. Center to point capital A also must be 0.7 meter. And this gap must be how much? This gap must be 0.2 meter. 0.2 meter. Now to the question. Rod is under equilibrium. Rod is under equilibrium. There are 4 forces acting on the rod. One is capital R upwards. 16, W, 8. These 3 forces acting on the rod in down direction. Capital R upward. The remaining 3 forces acting on the rod is down direction. Get the answer. Get the answer. Anyone can do the story. Get the answer. Get the answer. Then if I consider vertical equilibrium. So equilibrium of rod. Equilibrium of rod. What can I do? So we all know that. We all know the resultant force acting on the rod must be 0. Resultant force acting on the rod must be 0. If I consider vertical equilibrium, right? Then you can write down upward force must be equal to downward forces. It's up to you. Right, one can write down upward force must be equal to the downward forces. R must be equal to 16 plus W plus 8. One can directly write down like that. If not, one can say that upward force is positive, downward force are negative, and one can get the answer. I directly write down upward force must be equal to downward forces. Capital R must be equal to, I want to find capital R. Capital R must be equal to 16 downward force, 16 plus W plus 8 Newton. W plus 8 Newton. You can write down like this. If not, one can follow all steps like that. Resultant force, resultant vertical force must be 0. Then upward forces plus capital R. Downward force are negative. Minus 16 minus W minus 8 must be equal to 0. Then when you move that minus 16 minus W minus the right side, 16 plus W plus 8, same story. Then simplify. Capital R must be equal to 16 plus 8 is 24. 24 plus W. 24 plus capital W, equation 1. Is going to be equation 1. Equation 1. Right? Now you can't use force equilibrium resultant force 0. You can't use resultant force 0 concept and you can't obtain any other equation. You consider vertical equilibrium and resultant vertical force 0, you obtain one equation. Hereafter, because there are 2 unknowns in one equation, so you require another equation. To obtain that another equation, you should consider any point on the rod. Then we know if you can take any point on the rod, resultant torque at any point on the rod must be 0. Then you can take torque around point capital A, C, O, B. It's up to you. I thought of obtaining torque around point capital C. Why? See, already in my equation R and W is there. If I can find W, I can find R also. Then problem solved. If I take torque around point capital A, see, in case if I take torque around point capital A, R also produces anti-clockwise torque. W also produces clockwise torque. In my equation, R and W will be there. In that case also, I can get the answer. But somewhat complex. There will be 2 simultaneous equations and simplification will be a bit large. But if I take torque around point capital C, If I take torque around point capital C, R does not produce any torque around point capital C. Only W will produce a clockwise torque around point C. In my equation, there will be on one variable, that is W. The best option is take torque around point capital C. The second story, resultant torque at any point must be 0. If I take torque around point capital C, resultant torque around point capital C must be 0. What are the forces producing torque around point capital C? W produces clockwise torque around point capital C. Clockwise torques are positive. Then plus W, perpendicular distance to W from point capital C. Perpendicular distance to W from point capital C, that is 0.2. 0.2. Done. Then the torque produced by 8 Newton, it produces clockwise torque around point capital C, plus 8 into perpendicular distance to 8 Newton from point capital C. Here to here, the distance 0.2 plus 0.7, 0.9 meter. Then what else? This one produces clockwise torque, 8 Newton also produces clockwise torque. What about the 60 Newton? 60 Newton creates a kind of anti-clockwise torque around point capital C. Therefore, anti-clockwise torque means minus 16 into perpendicular distance to 60 Newton from point capital C. This gap is 0.5. 0.5 must be equal to 0. 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 Get the answer. You can find the capital W easily. You can find capital W easily. Right. For the simplification, we can do lots of stories. Okay. Now, if you multiply all terms by 10, you can remove this decimal point story. If you multiply all terms by 10, you can remove this decimal story. Right? If you multiply, even without multiplying, also you can get the answer. Right? Beta will multiply, right? Beta, if you multiply all terms by 10, multiplying all terms by 10. It's not compulsory. You can go with your own simplification. Right? Then 0.2 into 10 is how much? That's 2W. 2 capital W. Then if I multiply 8 into 0.9 into 10, 9 into 10, 9 into 8 is how much? If you multiply 0.9 by 10, 9 into 8 is how much? 72. 72 must be equal to how much? Must be equal to, if you multiply 0.5 by 10, okay, that is 5. 5 into 16 how much? That is 80. 5 into 16 is how much? 80. Minus 80 must be equal to 0. Plus 72 minus 80 is how much? Minus 8. Minus 8 right side, plus 8. 2W equals 8. 2W equals 8. What is your W value? But W value is how much? Just 4 Newton. Capital W is 4 Newton. Capital W is 4 Newton. Then what is your capital R value from equation 1? From equation 1 is your capital R value. Capital R equals 24 plus W is 4 Newton. 28. Capital R means what? 24 plus W is 4 Newton, 28. 28. Put some replies. How many of you got 4 Newton and 28 Newton for capital R and W reply? Put some reply. Yes, got the answer. Put some reply. Got the answer. Put some reply, everyone. Got the answer. Put some reply, everyone. Put some reply, everyone. If you got the answer for 4 Newton and 20 Newton, got the answer. Put some reply, everyone. Reply all. Reply all. Put some reply. Reply, everyone. How many of you got the answer? This question got the answer. Put some reply. Put some reply. Reply, everyone, if you got the answer. Only few replying. Only if you're responding. What about others not responding? Got it, right? Got it. Okay. Next question. Question number 20 also done. Start doing 23, 25, 15. 23. Question number 23. Start doing 23. Question number 23 story. Start. If you have doubt, you can put in the WhatsApp. If you're having doubts. If you're having doubts, you can put some reply in the WhatsApp. Get the answer. Get the answer. Get the answer. Now 0.2 W plus 7.2 minus 8 equals 0. 7.2 minus 8 is how much? Minus 0.8, not minus 0.6. Okay, that question. I hope you understand. Next idea, question number 23 idea. 23 idea, next story. Twenty-three idea. Next story. Now keep on working. Keep on working. Don't waste your time. Keep on working. Now you realize that after your term test marks, how many of you got results? If you got the term test marks, put reply to me, okay? For sure, doesn't matter. It's 90 or even it's 0 also doesn't matter. You want to reply. Okay, you want to respond. You want your term test marks. Okay? Right. Next question. Next idea. Question number 23, next idea. 23, next idea. So when we find the resultant moment, should we mention into and out of the book? I told you, even though I told you, right, in the beginning I told you normally the right way is we should mention into the board or coming out from the board. If not into the book or coming out from the book. But as a practice, even when you are doing the essay question also, you can mention in the clockwise direction, in the anti-clockwise direction, right? That is enough. This way, if you do the question, more than enough. But if you want to mention that story also, it's okay, mention. If you want to mention into the resultant talk, if you want to mention, take the clockwise talk. If not into the board, you can mention that story also. But not compulsory. Not compulsory. Not compulsory. Not compulsory. Not compulsory. Can you do little slowly, please? Am I too fast? Am I too fast? I feel like I have taken now more than 1.5 hours and only I have done 3 questions. Right? Keep on doing, keep on doing, keep on doing. Keep on doing. Because there is no way in the YouTube. Are there any option in the YouTube to check how many of you finished? Raise the hand. That story is not there. To check if someone finished, raise your hand. That story no. In YouTube's we can't get that story. That's the problem. It's a problem. It's a problem. Right? Better if they have that option and all, raise the hands. That story. It's really better, but I think no. That option is no, right? I think no. I think no, right? I think no. Okay. Next idea. Next idea. Next story. Start doing question 23. Start doing. Start this question. Start doing. Got it, but I can't send message in the chat because it says to join the chat. We need to have a channel. Got it, sir, but I can't send the messages in the chat because it says to join the chat. We need to have a channel. What is that? I didn't get that story. That means you should have an account in YouTube. Is that to put a chat in the YouTube channel? You should have a kind of account in YouTube. Is that what you are saying, girl? Is that what you are saying, girl? Is it? Oh God. Put some replies parallelly. What shall I do? I will do the next diagram with story. Today only questions mainly. Then after some time later, I will start the remaining last theory parts in force equilibrium. That triangle law and reciprocal of triangle law, Lam's theorem, whatever. Finished. Then enter the chapter is finished in hydrostatics, fluid dynamics next week. So we are getting a beautiful tute. All the tutes are modified. Okay, very beautiful tute you will get next week. Oscillation optics stories. I give a small introduction in that story. I did a small mistake actually. IR and ultraviolet I interchanged and I did a small mistake there. Please, someone only told that story. Mention, please consider that idea also. Right, I just removed it from YouTube because we know if someone sees that mistake, they will pop out until I don't know anything. That's why I removed from the YouTube, but I will upload in our website. People who knows about me, they know. But most of you, they don't know about me, they eagerly waiting to criticize something. Right? Human can do errors, we all can do errors, we all can do mistakes. Right? Question number 23, the mass of a ladder of length 5 meter. Nice question. You can learn something in this question, really nice question. The mass of a ladder of length 5 meter is 20 kilogram. It is in equilibrium. What is in equilibrium? Ladder is in equilibrium. Okay, in a manner that's its upper surface is in contact with a smooth vertical wall. Smooth vertical wall. Vertical wall is very smooth. Okay, right? And its lower end is contact with a rough horizontal ground. Rough horizontal ground. The lower end of the ladder is 3 meters away from the foot of the wall. If I do the diagram, that ladder is under equilibrium, but the diagram, everyone take your book and start on the diagram. Question number 23. 23 diagram. Question number 23 diagram. The diagram. The diagram. Rough horizontal ground and smooth vertical wall. There's a reason behind mentioning rough horizontal ground and smooth vertical wall. The reason. A smooth vertical wall. And what is our object? The object is the ladder. Ladder is our object. Ladder is our object. Okay? Okay. Now shall we mark the forces acting on the ladder? Forces. They have given point capital A, point capital B and angle theta 3 meter, 4 meter. This gap is 3 meter. And this gap is how much? This gap is 4 meter. Vertical height is 4 meter. This is point capital A, point capital B, point capital A and B. Point capital A, this point is point capital B. Point capital B, right? A, B is the ladder. I should mark the forces acting in the ladder, right? Now, this ladder is uniform ladder, therefore the weight is acting exactly in the middle of the ladder. The weight force is acting exactly at the center point of the ladder. Center point. Have they given the length of the ladder? Have they given the length of the ladder? Yes, they have given. The mass of a ladder is, the ladder length is how much? 5 meter. Mass of the ladder is how much? 20 kilogram. Then we all know that this weight, weight is 200 Newton. 20 kilogram is 200 Newton weight is acting exactly in the center, if not middle point of the ladder. If I mark the weight force, 200 Newton exactly acting at the center point of the ladder. The weight is 200 Newton. What can you say about the distance from point capital A to the center point? 2.5 meter. Distance from the center point to the point capital B is also 2.5 meter. 2.5 and 2.5 meter. This gap is how much? This gap is 2.5 meter. And distance from center point to point capital B. This gap is also 2.5 meter. 2.5 meter. Now shall we mark the forces acting on the ladder? One is the weight force, 200 Newton. What are the other forces acting on the ladder? Remember, this ladder is in contact with point capital A as well as point capital B. We know that whenever there is a contact between two objects, there are normal reaction forces acting on them perpendicular to the contact surfaces. This ladder is in contact with the horizontal ground at point capital E. Horizontal surface, ladder is in contact with horizontal surface at point capital E. Then the normal reaction force acting on the ladder at point capital A must be perpendicular to the contact surface. Red color pen important write down. Red color pen important write down. Red color pen important write down. If an object is in contact with the surface, write down. If there is a point contact between an object and a surface. If there is a point contact between an object and the surface. If there is a point contact between an object and a surface, the normal reaction force exert on the object. The normal reaction force exert on the object. The normal reaction force exert on the object. The normal reaction force exert on the object is perpendicular to the contact surface. Is perpendicular to the contact surface, right? And now, sir, this ladder is in contact with the horizontal surface. That contact is a point contact. This ladder is in contact with the horizontal surface, the small point. In that case, how to mark normal reaction force on the ladder at point capital E? The normal reaction force is perpendicular to the contact surface. The normal reaction force acting on the ladder at point capital E is perpendicular to the contact surface. Normal reaction force. Normal reaction force acting on the ladder at point capital E is upwards, vertical. Normal reaction force perpendicular. This idea. Let's take it as it has capital R1. No, you can take it as R. It's up to you. R1. This R1. R1 normal reaction force. R1. Okay. Now tell me. Now we all have climbed ladders, right? So we all have this hands-on experience. When someone does think that when your father or when your brother is climbing on the ladder, sometimes you are the one who is holding the ladder tightly without slipping the ladder. In case if the ladder slips, what would be the direction the ladder would slip? Do you think ladder would slip in this direction? If you slanted your ladder this direction, in case if your ladder is slipping, what would be the direction that the ladder would slip? This direction? Your ladder would slip this direction? No, right? Ladder would slip in this direction. Slowly, ladder would slip this direction. Then this ladder is tend to slip along the horizontal surface left side direction, right? This ladder is tend to slip along the horizontal surface left side direction. Then what can you say about the frictional forces acting on the ladder? If the ladder tends to slip along the horizontal surface left side direction, slipping like this, the frictional force acting on the ladder at point capital is right side direction. As they mentioned, horizontal ground is rough. There are frictional forces acting on the ladder as well. If you mark the frictional force acting on the ladder at point capital A, ladder tends to slip left side direction. Therefore, the frictional force always opposite to the motion. Frictional force acting on the ladder at point capital A must be right side direction. Frictional force right side direction. Let's take it as F1, no, F or something, F1 something. Frictional force acting on the ladder at point capital E is F1. Then I marked 200 weight force acting on the ladder. Normal reaction force acting on the ladder at point capital is R1 upwards. Frictional force acting on the ladder at point capital is right side F1. What else? They mention vertical wall is smooth. Therefore, there are no frictional forces acting on the ladder at point capital B. But still, ladder is in contact with the vertical wall at point capital B. Whenever there is a contact between two objects, there are normal reaction forces. This time, ladder is in contact with the vertical wall. Basically, it's a point contact. Then the normal reaction force acting on the ladder at point capital B must be perpendicular to the contact surface. Contact surface vertical, the normal reaction force acting on the ladder at point capital B must be perpendicular to the contact surface. Then how would you mark the normal reaction force acting on the ladder at point capital B? This direction. Now these are practice. I can't teach you these things in the theory, okay? Theory, common stories we are explaining, but these are by doing questions only, you will understand different stories. Okay? Okay, I will start that night camp story from February. I told you, sometimes midnight 10 a.m. to 2 a.m. I will do twice in a month. I will do to do more questions. Theory can finish now. Theory is almost finished. Now we have taken this much of time for what? Right? To explain, to do the questions. Theory can finish. Everyone can finish. But want to do the parallel, want to do the questions. You all have that exposure now. After doing the first term test only, you will realize that. You'll realize lots of things. I think that the Monday class also I told you, it's not all about completing the things as soon as possible. It's really better. It's really better that if you can finish the syllabus early, really better. But beyond that, the most important thing in the first stage is doing enough number of questions till you are very familiar with the stories. Right? Please give priority for that. Some students are there, they are eagerly manipulate you. No, this is the right way. We'll finish syllabus, that sir is finishing quickly, we'll go there and here. Please don't give priority for those things. You just think yourself, what is the right thing? Right thing. Always follow the right thing and do. Please explore lots of questions. If not, no use. Even you complete something early also, if you're not exposed to that number of questions, when you do the exam paper only, you understand that you can't even do any question. You've done this part, but you can't do. Because lack practice. I'm telling that. Even I'm doing this much number of questions also, still I'm telling that. No, number of questions I discussed is not sufficient. Then you understand what will happen in other classes. Right, that story. Okay. Then the normal reaction force acting on the rod at point capital B is what? Left side direction. Time is almost 8 o'clock. We are taking the break at 9 o'clock. Take the break at 9 o'clock, okay? 7, 9. Normal reaction force, that is capital R2. Capital R2. Perpendicular. This is horizontal normal reaction force. Vertical normal reaction force. How many forces acting on the rod? Finally, there are 4 forces. R1, F1, 200 and R2. There are only 4 forces. Now only understand there is an object, that is a ladder. There are 4 forces acting on the ladder. R1, R2, capital W weight 200 Newton and frictional force F1. This idea clear, hands, put some reply. Everything, the way that I mark the forces, R1, R2, F1 especially. This idea, there are 4 forces acting on the rod, the ladder. This idea clear, put some reply everyone. Put some reply, this idea is clear, everyone put some reply. If the idea is clear, everyone put some reply. So, is it a must for all the forces acting on the object to meet at a common point? Our schools are taught that way. We will teach that story today. It's not like that. We talk about force equilibrium under 3 forces. Today we will learn that story. If I will tell you the story, okay? That's what today we will learn. Right? If there are more than 3 forces, it's not compulsory. Okay? Okay? I will tell, don't worry. I will tell the story. I will tell you that story. Today we will learn that story. The theories. So we are doing that, we'll do some questions, and we'll focus after discussing 25, 15. Then we'll go back to the theories and again we'll do the questions. Small theory part is there. We can finish today entire lesson. Next Monday, optics properly optics diffraction of light through plane surface is Monday, 6 to 8:30. Not putting long hours for now. Then I will definitely extend that 6 to 8:30 to 6 to 11 in not now, after 5-6 months later, after 26 batch finish theory, mostly after May onwards, May or June, maybe May. Now just roughly 6 to 8:30 parallel doing. That's the way. Put some replies, all clear. Put some reply, everyone. Put some reply, all clear. Put some reply, everyone. Everyone put some reply. If all clear, put some reply, everyone. All clear, put some reply, everyone. Frictional force, F1 stand for frictional force, cause the ground is rough. Yes, it's a rough ground. Therefore the ladder tends to slip to the left side of the ground. Right? What will happen when you release the maybe when you release the ladder? This ladder can slip to the left side. Then what would be the frictional force acting on the ladder? Right side. That is F1. The frictional force acting on the ladder at point capital is F1. Right? Now get the answer. Now they are asking in the question. In the question they are asking what? In the question they are asking what? They are asking the question. Forces, okay, now 3 meters away, okay, we have marked every story properly, okay. Force on the ladder by the wall. I want to find this R2. What else? Reaction force exerted on the ladder by the ground. Reaction force exerted on the ladder by the ground. Right? Now that means I want to find R1, F1 both. Remember, okay, I will give us a point also. Okay, first of all, we'll find this R2, R1, F1. I want to find R2, R1, F1. Right? But you can easily find R1. There are 4 forces acting on the ladder. R1 upward force, 200 weight downward force, F1 R2 right side and left side forces. Anyone can tell easily what is your R1 value. R1 must be exactly equal to how much? 200. So ladder is under equilibrium. If you consider equilibrium of the ladder, right, resultant force must be 0. If I consider vertical equilibrium, sir, vertical equilibrium of the ladder, there are only 2 vertical forces acting on the ladder, that is R1 upward, other one is 200 downwards. There are only 2 vertical forces. R1 must be equal to 200. Very simple. R1 must be equal to, say, 200 Newton. 200. Simple. Now I found R1. Now I want to find R2 and I want to find F1. Also, sir, just consider horizontal equilibrium. There are only 2 horizontal forces, F1 right side, R2 left side. If I consider horizontal equilibrium, sir, right side force is F1, left side force is what? Left side force acting on the ladder is capital R2. F1 must be equal to R2. I want to find F1 and R2. Now, equation 1. F1 is equal to R2 value. Equation 1. Right? So now I use this ladder is under equilibrium. We know the 2 conditions. If the ladder is under equilibrium, resultant force must be 0. The second condition must be resultant torque must be 0. I apply this resultant force must be 0 story and I obtained all the possible stories. But still I can't find F1 R2 values. Therefore now we all agree I should consider a point and I won't take torques. I should obtain torques. Which point are you going to take the torque? We know any point, no matter. When you consider any point on the ladder, resultant torque must be 0. Right? Better, ni? Which point are you going to the torque? Point capital A or point capital B or point capital O? if I ask you to take the torque around, which point is suitable? I want to find R2O F1. Better if I can take torque around point capital A. Why? We all agree, ladder is under equilibrium. If we take torque around any point on the ladder, resultant torque around that point must be 0. But the most suitable point is point capital A. If you take the torque around point capital A, R1 F1 passes through point capital A. R1 F1 passes through point capital A. Therefore, these two forces do not produce any torque around point capital A. Then only 200 produces a torque around point capital A clockwise torque. 200 produces clockwise torque around point capital A. R2 produces anti-clockwise torque around point capital A. 200 clockwise torque around point capital A. R2 produces anti-clockwise torque around point capital A. That's it. That's it. That's it. But question is somewhat tricky. Question is somewhat tricky. Look here. They have given this angle. This angle theta. This angle theta. AOB, this point capital C. Just consider ABC right angle triangle. ABC right angle triangle. What is sine theta? If you consider ABC right angle triangle, I will draw it. We have done this idea many times in most of the questions. But it's okay. Right? That's okay. That's okay. And learn something from every question. I'm increasing the question discussions, durations, upcoming days, this month onwards, long durations. Long durations. We are working for a goal. It's a big goal. It's a big goal. 3 meters. 3 meters. And this gap is 4 meters. BC length is 4 meters. BC is 4 meters. What can you say about AB? AB is going to be 5 meters. Then what is your sine theta value? Opposite over hypotenuse. Sine theta value is how much? Opposite over hypotenuse. Opposite is 3 meters. Hypotenuse 5 meters. What is your cos theta value? Cos theta value going to be adjacent over hypotenuse, 4 over 5. I will explain why these two came. Right. Now take the torque around point capital E. The next condition. The next condition we all know that, sir, if that ladder is under equilibrium, resultant torque at any point on the ladder must be 0. Resultant torque at any point on the ladder must be 0. Even if you take the torque around point capital C. Even if you take the torque around point capital C also, resultant torque around point capital C must be 0. And then I consider clockwise torques are positive, anti-clockwise torques are negative. Around point capital E. Around point capital E, 200 produces clockwise torque. Clockwise torque. Therefore, plus 200. Plus 200. The many people have the problem, sir. The problem is I can take the torques. But the struggle is when I find the perpendicular distance to the force from the point, I am doing lots of mistakes, sir. When I find the perpendicular distance story, I am doing lots of mistakes. Lots of mistakes. Okay. See, tell me, this 200 produces a clockwise torque around point capital A plus 200 into perpendicular distance to 200 Newton from point capital A. Your 200 is a vertical force downwards, okay? From point capital A, if you draw a perpendicular distance to the vertical force from point capital A, if you draw a perpendicular distance to vertical force from point capital A, that perpendicular distance is going to be a kind of horizontal length. Then tell me what is the perpendicular distance to the 200 Newton from point capital A? That must be this gap. The perpendicular distance to 200 Newton from point capital A is this gap. This gap how much? F angle. F angle, this angle is theta. I taught you one story, if you can remember. Work energy power also I taught you if you know the hypotenuse and I know many forget. If you know the hypotenuse value and if you know the angle, let's say hypotenuse x something, then if I ask you what is this length in terms of x and theta, you should be able to answer very quickly. If you know the hypotenuse and if you know one of the angles, if I ask you what is this length, you should be able to get the answer very soon. So x sine theta, x sine theta. What is length? This length must be x cos theta. I explain why. Then tell me, I want to find this distance, this small right angle triangle. What is its length? 2.5 sine theta. All good? This small right angle triangle, hypotenuse is 2.5, this angle theta. Then what is length? This length 2.5 sine theta. This gap is how much? 2.5 sine theta. If you have doubts, ask. 2.5 sine theta. This gap is how much? 2.5 sine theta. 2.5 sine theta is this gap. This gap is how much? 2.5 sine theta. This length. Then plus 200 into 2.5 sine theta. 2.5 sine theta. Sine theta value I know. Right, so actually I am finding the resultant torque around point capital A. I am finding resultant torque around point capital A, my bad. I am finding resultant torque around point capital A. Then capital F1, R1 do not produce any torque around point capital A. 200 produces clockwise torque around point capital A plus 200 into 2.5 sine theta. Then what about R2? So R2 produces anti-clockwise torque around point capital A. Therefore minus capital R2. Minus capital R2, I want to find capital R2 only. Minus capital R into R2 into perpendicular distance to R2 from point capital A. Vertical distance. Many struggle. Is the R2 line of action of the R2 force. If you draw a perpendicular line to this R2 from point capital A, if you draw a perpendicular line to R2 from point capital A, it's going to be a vertical length. It's going to be a vertical length. It's going to be a vertical length. Tell me what is length? How much? This length. A to this vertical line length is how much? 4 meter. 4 meter. This gap how much? This gap must be 4 meter. This gap must be 4 meter. 4 meter. Learn properly. Then R2 produces anti-clockwise torque around point capital A minus R2 into 4. R2 into 4. R2 into 4. R2 into 4. Keep on doing. Keep on doing. Keep on doing. Keep on doing. R2 into 4. So must be equal to 0. Now can get the answer. And then for R2, we know for R 200. 200 into 2.5 means we can write 5 over 2 also. Okay, 2.5, that means 5 over 2. Okay, 2.5 means what? 5 over 2. 5 over 2 into sine theta means we know sine theta means 3 over 5. Sine theta means 3 over 5. 3 over 5 must be equal to minus R2 into 4 means 4R2 right side. 4 into capital R2. I want to find capital R2 value. I want to find capital R2 value. Then this 5 cancel out. Right? Then here 200 over 2 is how much? 100. 200 over 2 is 100. 100 into 3 is 300. 300 over 4, how much? 75. R2 is how much? 75 Newton. R2 75 Newton. Finally. 75 Newton. If you are R2 75 Newton, from equation 1, F1 is R2. What is the frictional force acting on the object? Therefore, from equation 1, F1 is how much? F1, the frictional force is also equal to R2. F1 is also 75 Newton. Nice question. Nice question, 75 Newton. Nice story. Nice story. Right, nice story. Nice story, next idea. Nice story, next idea. Next story. Keep on doing. Keep on doing. Keep on doing. Next story, nice story. Very beautiful story, very nice story. If you have doubts, you ask in the WhatsApp for today. Next week we are doing only Zoom. Why do you take talk around C? I made a mistake. I made a mistake. I am taking the talk around point capital A only. Mistakenly put C. Okay, made a mistake. Right? Can you explain how F1 and R2 are equal? Is it corresponding angle theorem? No. Horizontal equilibrium, right? F1 right now, when you consider horizontal force acting on the ladder, there are only two forces horizontal. F1 right side horizontal force, R2 left side force. We know that if the ladder is under equilibrium, horizontal right side force must be equal to horizontal left side force. Therefore, F1 must be equal to R2. That idea. That idea clear, right? Nicely. Nice story. Time is 8:10. 9 o'clock we are taking a break. 9 o'clock we are taking a break. Nice story. We'll discuss question number 25 and we'll decide to do the theory. Question number 25 story. Start in 25. Start in 25 next story. Question number 25. Everyone put some thumb, everyone, if you can access that chat. Next week we are doing through the Zoom only. Right, upcoming months also I will stream as YouTube as well as Zoom. And therefore I think many have a small uncomfortability when you are putting some doubts in the group and all. Next week onwards this won't happen. But temporarily everyone put thumbs. If all clear, put some thumbs. If all clear, put some thumbs everyone. If all clear, everyone put some thumbs. If all clear, everyone put some thumbs. Right, everyone should work. This is somewhat very confusing lesson. Trust me. This is really confusing lesson. I know that. Everyone put some thumbs. If all okay, put some thumbs. Put some thumbs. Put some thumbs. Simple ni? Simple. All good ni? Nice story. Learn, I think ni? Now you understood ni? Right, keep on doing next story. Question number 25. Start doing next story 25. 25, I will tell you what you want to find, okay? In 25 start, in 25 you want to find actually, in question number 25, you want to find actually, in 25 you want to find actually, you want to find that F capital M and Fj. Consider that hand rod arm is under equilibrium. You want to find that F capital M and Fg. Find F capital Fg. You don't want to read anything. Look at that figure 2. Look at the figure 2 and get the answer. Look at the figure 2 and get the answer. Structure of a bone and muscles of arm of a person is shown in the figure. When a mass of 5 kg is lifted, the forearm is horizontal while the upper arm is perpendicular to it. The equivalent mechanical system of the arm is given in figure. This type of question they have given 2000, I can't remember the year, 2014 or 13 something, essay question. One complete essay question came from this idea, right, in the mechanics essay question in that year, right, in the year, okay. Right, you basically draw that diagram, figure 2 diagram in your book and start finding Fm and Fg. Very simple. Very simple. Question number 25, very simple, not difficult. 25. Start finding Fm and Fg. If I mark the forces, there are how many vertical forces? All the forces are vertical, therefore easy. Fj, Fm2, then 20 Newton, 5 kg is 50 Newton. There are only 4 forces, Fj, Fm. Fj downwards. I want to find Fj. This point is point capital E, point capital E. And F capital M is upward. F capital M, I want to find F capital M. This point is point capital P and distance from point capital E to P is 5 centimeter. This point is point capital P, this gap is how much? 5 centimeter. 5 centimeter gap, right? Other force is 20 Newton. 20 Newton. 20 Newton. Newton. Distance to 20 Newton force from point capital E is how much? 15 centimeter. This gap is how much? This gap is 15 centimeter. this gap. You want to find Fg. Here he is holding a 5 kilogram weight. Basically, it's a 50 Newton weight. Distance to 50 Newton weight from point capital is how much? 35 centimeter. Simple. There are 4 forces acting on the arm. There are 4 forces acting on the arm. That's it. Distance to 50 Newton weight from point capital is how much? 35 centimeter. Want to find Fm and Fg. Simple. Really simple question. There are different ways to get the answer. Okay? Based on the point that you consider, there are different ways to get the answer. Now, I thought of taking the torque around point capital E. We know the arm is under equilibrium. Resultant torque at any point must be 0. Resultant torque around point capital E must be 0. Right? Consider the equilibrium. Right? If I did the torque around point capital E, resultant torque around point capital E must be 0. Then this Fm creates anticlockwise torque around point capital E. Therefore, minus Fm into 5 centimeter. Minus Fm into 5 centimeter. Now, you can convert to meters also, but in this scenario, even without converting into meters also, you can get the answer into 5 centimeter. If you want to convert to meters, better. Right? As a practice, you guys convert, in case if they have given the distance in centimeter, as a practice, convert to meters. But I am doing this question without converting, but when you are doing, please convert and do it. This 20 Newton creates a kind of clockwise torque around point capital E. Clockwise torque around point capital E, 20. Clockwise are positive, plus 20 into distance 20 Newton from point capital E. This gap is how much? 50 centimeter. This gap 15. This 50 Newton creates a clockwise torque around point capital E. Clockwise torque. These two creates clockwise torque. This one creates anti-clockwise torque. Clockwise torque 50 plus 50. Perpendicular distance to 50 Newton from point capital E, this gap. 35 centimeter. The resultant torque around point capital E must be 0. Why? Rod is under equilibrium. Arm is under equilibrium. Get the answer. Get the answer. And then minus 5 Fm, right side. It's 5 Fm. 20 into 15, how much? Okay, better we can, okay, 20 into 15. 20 into 15 plus 50 into 35 must be equal to 5 Fm. 5 into Fm. 5 into Fm. And now you can divide all the terms by 5, right? If you divide them by 5, divide everything by 5. Small simplification things. If not, you can multiply and you can simplify it. But if you divide by 5, it will be easier to get the answer, right? But you don't want to show like this. You can, in your mind, you can do these things. But in order to understand everyone, I am following all steps. But if you feel like you can eliminate some steps in the question, please eliminate and try to do it. But if you experience when you are eliminating some steps and when you are getting the answer, if you feel like your answer getting wrong, that means still please follow all steps. Right? Then here 1 hits 3, 20 to 360. 60, here 50 of 5 is 10, 10 into 35, 350. 350 must be equal to how much? Must be equal to 5 cancel out. F capital M. F capital M. Substitute F capital M. F capital M is how much? 350 plus 60 is 410. How many of you got 410? Put a reply. How many of you got F capital M as 410? Put a reply. If you got 410 as your F capital M, put some reply, everyone. If you got 410 as you are F capital M, put a reply, everyone. Put a reply, everyone. If you got 410, put a reply, everyone. Put a reply, everyone. Put a reply, everyone. If you got 410, put a reply. Put a reply, everyone. Put a reply, everyone. If you obtain 410 as your force, put a reply, everyone. Reply everyone. Reply everyone. You got it right? Got it, ni? Simple, ni? All good, right? Simple. Simple. Now, I don't know why now our theory classes, there are around 40 people joining live, right? But today, I think there's a kind of reduction in the people who join live. I don't know what is the reason. Okay, if you're experiencing any difficulties, put a small reply, okay? Right? Right? If you're experiencing difficulty, put a reply, because everyone should join the live class as much as possible. That is important, me. That is important. And once again, I will give one last time January classes recordings I will extend. January class recordings I will extend once again today, if not tomorrow morning I will extend. January classes, the theory recordings and paper class, every recording I will extend till 20th February. But February recordings I don't extend maximum, right? Once I uploaded the recording, it will be maximum remain in the website, maximum 7 days. 7 days. That's better, right? That is better. That is better, right? If I put 10 days also, it's too much, right? I can give 10 days for the recording, but it's too much. I will give January class recordings, I will extend till February 28th. February class recordings, the expiry date is 7 days. That's better. If not, you guys don't watch the recordings. Most of you don't watch the recording. That's what happening. Right? Okay, comparing with the positive giving unlimited access to the recordings and negatives are too much. Okay, right. Then if I know capital FM value, I can easily find FJ value also. If you find the FJ value, find FJ value, find FJ value. If you find FJ value, find FJ value. And now you can, now since you know this F capital M value, if you want to find Fj, you can talk about vertical equilibrium, resultant force 0. If the rod is under equilibrium, resultant force must be 0. So we know that equilibrium, resultant force must be 0. Resultant force must be 0. If you consider vertical equilibrium, resultant vertical force must be 0. That means upward force must be equal to downward forces. Upward force Fm. I want to find Fm only. Fm. No, I found Fm. I found Fm. That is how much? That is 410. Fm is how much? 410. That must be equal to downward forces. That is Fj. I want to find Fj. Fj plus 20 and then plus what? Plus 50. Plus 50. Then what is my Fj value? If I find Fj value is how much? My Fj value is going to be here 20 plus 50, 70. 410 minus 70. 410 minus 70 is how much? 340. Fj value is how much? Fj is going to be equal to 340. 340 newtons. 340 newtons Fj value. Simple. Nice question. Real nice question. Nice theory. Nice idea. Then we can talk about 15 story. We'll do 15 bit late. Right, okay. Then we'll go back to theories once again. We have small theories pending. Can someone take your tutor, tell me the last theory section we discussed in the class? Can someone send me a WhatsApp photo? The last theory section we discussed in the class. The last theory section. The last theory section we discussed in the class. Can someone put a reply? 9 o'clock we'll take a break. The last theory section we discussed in the class. The last theory section. Reply someone. The last theory section. The last theory section. The last theory section. We talked about equilibrium of two forces, right? I think we talked about equilibrium of two forces, right? Okay. Okay, ne? Right, okay. We talked about equilibrium of three forces as well, ne? As well. Okay, right. Okay. Right, that idea, okay. Equilibrium of three forces, three parallel forces. Okay. Right. Okay, right. Thank you everyone for sending. Everyone sending. Mr. Nuha, Fatima, then Shada, Takira, Naz, Sharfa, Raida. Thank you everyone. Thank you everyone. Next theory. The last three sections. We are completing the theories and we are taking the break. Then we are doing questions. Next day, new chapter. Center of gravity. Normally I will do at the end. Learn things properly. Physics is a subject, it's not easy as you think. But if you learn properly, it's easy. Expose lots of questions. Try to maintain your marks above 50. Not in your, maybe not in your school term, especially my papers, the papers, right? Try to maintain marks above 50 as an average. If not, at least try to reach the marks above 50 before at least 2 months before the exam. Then A is guarantee. A is sure. Okay. Right, 22 done, 23, 25 done. We have obtained a good exposure. Next theory idea. Next theory idea, next story. We'll take a break at 9 o'clock. Stay focused. Stay focused. Don't you try to watch the recording once again. Joining live, and again, if you want to clear something, if you watch the recording, means there is no point. Therefore, now itself, put everything in your mind and complete it. Don't you spend time to 1 second watch. Don't do that. Because for an A-level student, we don't have that much of time to repeat the same thing again and again. As an A-level student. Okay? Right. Okay. Okay. Right. Okay. Now I think we discussed till page number 38, page number 39. Page number 39 story, 39 and 40, only 2 pages. 39 and 40. And also some students, please tell me, when you consider page number 1 to 39, if I missed anything in the theory, in the tutor, if there are any blank, someone put a message, okay? Put a message, okay? Page number 39 story, right? Now actually we were talking about equilibrium ideas. Look here everyone. Now we talked about equilibrium of two forces. Look here. Now one student asked a question also, when there are forces, they should meet at the same point. That idea. I will explain now. Carefully listen. Listen carefully. Right? Okay. Now we are talking still equilibrium of forces. Already we learned that when object is under equilibrium due to two forces. What are the characteristics of those two forces? Those two forces must be equal in magnitude, opposite in direction, and both the forces must be collinear. Should act in same line. When talking about equilibrium of two forces, we learned. Equilibrium of two forces, we learned. We learned what? It is your object. It is object is under equilibrium due to two forces. Both the forces must be equal in magnitude, opposite in direction, and they must act in same line, collinear forces. If I mark one force capital F1, other force must be capital F2. They are equal. This force capital F1, this force capital F2, they are equal. They are equal. Then we talked about equilibrium of an object under three coplanar forces. Equilibrium of an object under three coplanar forces. Then we can talk equilibrium of an object under three coplanar forces in two different cases. Those three coplanar forces can be parallel to each other. If not, those three coplanar forces can be inclined to each other. I already discussed if three coplanar forces are parallel to each other, what are the conditions? If three forces are parallel to each other and if the object is under equilibrium, what are the characteristics idea? I taught you. Once again, I'm briefing. Equilibrium of three forces. Equilibrium for object under three forces. Equilibrium under three forces. Equilibrium under three forces. Under three forces. Three forces. This idea. This idea. Now we can talk about equilibrium of an object under three forces in two different cases. In first case, I taught you. Second case only, I didn't teach you yet. In case number one. In case number one, you can remember. Suppose if the three forces are parallel to each other and if the object is under equilibrium, parallel forces. Parallel forces. Right? Let's consider this object. There's an object. And there are three parallel forces acting on the object. Very careful in theory. There are three parallel forces acting on the object and object is also under equilibrium. Object is also under equilibrium. If I mark those forces F1, F2 upward for an example. F1, F2 upward and let's say F3 is downward direction. F1, F2 forces in upward direction. F3 is in downward direction. Shall we put some values for F1, F2? Tell me now, F1 is for example 10 Newton. F2 is 50 Newton. F1 is 10 Newton for an example. F2, 50 Newton. Then what should be the F3 value? If this object is under equilibrium, we know the resultant force acting on the object must be 0. There are two upward forces, 10 and 15. F1, F2. What must be the F3 value? Definitely F3 must be 10 plus 15, 25. Then only resultant can be 0. Then only object can be under equilibrium. Then remember the first characteristic is, the first story is, if the object is under equilibrium due to three parallel forces, it's not compulsory for those forces to meet at same point. It's not compulsory. If there are three parallel forces acting on the object and if the object is under equilibrium, it's not compulsory for the forces to meet at a common point. Now, do you think the forces F1, F2, F3, are they meeting at same common point? No, right? F1 line of action is this line. F3's line of action is this line. F2's line of action is this line. They are not meeting. The lines of actions are not meeting. They are not meeting at a common point. They are not meeting at a common point. They are not meeting. They are not meeting. But always remember, resultant of two force. Now there are three parallel forces. Resultant of two forces always equal to the magnitude of other force. Resultant of two forces. What is resultant of F1 and F2? 25. That is equal to the magnitude of other force, 25. If it is these two forces, if you take these two forces, what is resultant of these two forces? 15 upward, 25 downward. What is resultant of these two forces? 15 upward and 25 down means resultant is 10, right? That is equal to magnitude of other force, 10. If you take these two forces, 10 upwards, 25 downwards, resultant of these two is how much? 15, that is the magnitude of other force. Simple story. Remember, when three parallel forces acting on the object and if the object is under equilibrium, it's not compulsory for the forces to meet at a common point. The next story is resultant of two forces always equal to the magnitude of other force. That story, okay, remember. I think we talked that story. In your tute also, we talked that story. The tute also, we talked that story. I have given that story. Next one is equilibrium under three coplanar forces that are not parallel. That means suppose if an object is under equilibrium due to three inclined forces, then what are the conditions? What are the stories? And now listen to the story. Case number 2, Object is under equilibrium due to 3 inclined forces. Case number 2. Case number 2. Very important story, okay? Now, many have a problem with this story only. Right? I have seen your term test also, this story came. Inclined forces, not parallel, means if the 3 forces are not parallel, means they are inclined forces. Inclined forces. Inclined forces. If I draw the object, this is the object, and there are 3 forces acting on the object. Let's say one is F1, F2, F3. One is F1, F2, F3. F1, F2, F3. The F1 force. Look very carefully. F1 force. Right? And if I draw the F2 force, I'll extend the line of action of F1 force. The line of action of F1 force. Other force acting on the object is F2. This force F2. If I extend the line of action of F2 force, the other force acting on the object is F3. F3. Right? Very important point. In the MCQs, they test this story. In my papers also, you can see the story in my paper MCQs. Right? Remember, if an object is under equilibrium due to 3 inclined forces, definitely, 3 inclined forces, okay? Definitely, line of action of those 3 forces should meet at same common point. Whenever you see an object having only 3 forces, definitely line of action of those 3 forces should meet at same common point. Same common point. Do you understand? If the object is under equilibrium, and if there are 3 forces acting on the object, their line of actions must meet at same common point. Same common point. Right? That story. But, okay. Right? That story, okay? That story. That story. If you have doubts, ask, okay? This story. Then take your tutor and refer it. Take it. If you have doubts, ask. Whenever you have doubts, you want to ask, okay? Then page number 39, the tutor. Equilibrium under 3 coplanar forces that are not parallel. Inside the bracket, write down inclined 3 forces. Inside the bracket, inclined 3 forces. I have given, since the lines of action of forces F1 and F2 intersect at point O, the resultant of these forces will also pass through point O. Therefore, equilibrium force F3 must act along a line that passes through point capital O to balance the resultant of F1 and F2. Okay, this idea. Now, everyone carefully listen. Now, if I ask you a question, if you have doubts, please at least put some your doubts in WhatsApp chat. If you have some doubts, put your doubts in WhatsApp chat at least, okay? Now, I mentioned this object is under equilibrium. These are 3 inclined forces. They are meeting at one common point. Clearly. Now, what can you say about the resultant of F1 and F2? Sorry. What can you say about the resultant of F1 and F3? Remember, the resultant of F1 and F3 must be equal in magnitude of F2, right? If you find the resultant of F1 and F3, resultant magnitude should be equal to F2, right? Opposite direction. See the logic? When you consider F1 and F3, the resultant of F1 and F3 should be equal in magnitude with F2, opposite in direction with F2. For example, if I draw F1 and F resultant, that is F3. Resultant of F1 and F3 is, I just take it as it's a vertical one, okay? That is, let's take it as R1 something. Remember what I have done? Actually, there were 3 forces. I reduced this F1 and F3. Resultant of F1 and F3 is R1. That means instead of F1 and F3, I represented R1. Then I reduced 3 forces into now 2 forces. Then also object must be under equilibrium. Actually, there were 3 inclined forces F2, F1, F3. Object is under equilibrium. What I have done is I obtain resultant of F1 and F3. That is R1. And now what happened? Earlier there were 3 forces. Now there are only 2 forces. One is F2 upwards, for example. Other one is R1 downwards. It becomes object under equilibrium with 2 forces. If the object is under equilibrium with 2 forces, they must be equal in magnitude, opposite in direction, they must be collinear. Therefore, you want to understand this R1 value must be equal to F2 value. Do you understand? They are opposite. That's story. I think you understand the idea, right? For example, then forget about next story. When you consider resultant of F2 and F3, let's take it as R to something. Resultant of F2 and F3, let's take it as R to something. Resultant of F2 and F3, that is R to something. From R to something. Remember, this R2 must be equal in magnitude with F1, opposite in direction with F1. That idea. Right? I hope you all understand, right? If you are not, ask. When you consider resultant of F2 and F1, that must be opposite to F3, equal magnitude with F3. That story. That idea. If you consider F1 and F resultant F3, sorry, F1 and F2 forces, resultant is, let's take it as R3. The resultant must be opposite to F3, R3 and F3 must be equal magnitude. That logic is clear, right? If you have doubt, ask. Put some replies, all clear, put some replies. This idea, this logic clear, everyone put some replies. Theory finished. This idea clear, everyone put some replies. This idea is clear, everyone put some replies. If you have doubts, ask, at least WhatsApp. Right? Don't keep any doubt. Don't keep it, because I am not teaching in that level. Right? Therefore, any doubt, ask. It's not a theory. I am not bothering with the speed. Okay. Whoever joined to the live class, I want to do a kind of justice for them. Right? Put some replies. All clear. Everyone reply. Everyone reply. Reply. Everyone is logic. Now, sometimes your teacher told. I think one told. So my teacher told. Even an object is under equilibrium with 4 forces also. Are those 4 forces must meet in same point? Yes. Why? What the reason? Because you can reduce that 4 forces into 3 forces, right? Now there are 4 forces acting on. Now your teacher told. What your teacher told? Your teacher told that, sir. Now if there are 4 forces acting on an object, and if the object is under equilibrium, are those 4 forces must meet at the same point? Yes. You know why? You can reduce that 4 forces into 3 forces, right? If you take 2 forces, then if you obtain the resultant, then it will become a 3 force system. That object is also under equilibrium. There are 3 forces. Then definitely those 3 forces must meet at same point. That story. That story. If you have doubt, ask. Okay, don't keep any doubts. Okay. Break is 9 o'clock. Break is at 9 o'clock. Okay. Cool princess. What's your name, cool princess? Break. We'll take it at 9 o'clock. 9, 15 minutes more. We'll take a break at 9 o'clock. It's tired only, but it's the way. It's the way. Right now we want to work more. Right. So wanna complete page number 14 and 15. Okay, we'll do that story later. Sir, we didn't write any note in page number 14, 15. All right. Right. Okay. Okay. Right. 15. Work done by an external force on a rough surface. We wrote something in our notebook, right? We wrote something in our notebook, right? I can remember. Okay. I think we wrote something in our notebook. That logics and ideas. Okay. Done, right? Okay. Then write in the tute. In the tute, the given space. Next story. Please mark these ideas. Whatever the thing I explained the board, you write on your tute. This story side is logic. Many people forget the stories. And the tute, next story. The tute, next story. Next story. right? Now, okay. Next class onwards, I'm doing something, okay, to show me and leave stories happening from next class onwards, right? Because we are zoomed, because YouTube we can't do that story. In YouTube, when you are stream the class, then after class finishes, I will give a set of questions, right? Till you get the answer, you can't leave, but it's not a compulsory thing. People who want to leave, I don't disturb. They can leave, right? It's a common practice I do in my physical class, right? Normally, after I finish my theory class, even though I finish the class at 5:30, till they finish 3 questions, they can't go home. Even though their parents are outside also, it's not my concern. If someone finish those 3 questions in 5 minutes, they can go home. Likewise only for online also, I thought of doing that story for the people who want to do those now, because if you want to self-evaluate, sir, you taught us a lesson today, for example, you are teaching a lesson, now you are learning a lesson today. A sir is explaining everything properly. I also feel like I understand everything. And so we are doing set of enough questions in the class also. But to self-evaluate, so we should do a kind of self-evaluation. Whatever the theory and questions we have done today, in case if a similar question asked tomorrow in my unit test, if not tomorrow in my exam, will I able to get the answer? To do a self-evaluation after class finishes, right? I will give 3 questions. You want to the 2 questions maybe, right? Then you want to show me and you show me and leave means you can take a photo, right? When you get stuck, you can put WhatsApp, you can take pictures and send me and say I got stuck here. What should I do? Then I will see your messages and I will guide you. Right, that way complete it and will stop the class. But it's not compulsory. People who want to leave can leave, because I don't want to be a kind of additional burden for others. But I want to do my part properly, right? Because I want to make this online class more into physical way, right? I'm trying my maximum to make you not to feel it's online, right? That story. And now the topic under conditions for equilibrium of three non-parallel forces. There are 2 conditions. Number one, red color pen, write down. Number one, red color pen. Red color pen, number one, write down. Red color pen, number 9 o'clock break. 10 minutes to go. Red color number one, write down. The line of action of three forces should meet. The line of action of three forces should meet. The lines of action of three forces should meet. The lines of action of three forces should meet. At a single point, comma. 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 At a single point, full stop. At a single point, full stop. Inside the bracket, write down. Inside the bracket, write down. The meaning is the forces are convergent. Inside the bracket, write down. The meaning is the forces are convergent. The forces are convergent. The forces are convergent. Right, number two, write a red color pen. Number two, red color pen. The vector sum of three forces must be zero. That's obviously. If the object is under equilibrium, resultant force must be zero. Number two, write down. The vector sum of three forces must be zero. The vector sum of three forces must be zero. Must be zero. And now the last theory stories, we are not that much frequently applying to questions. If you know the vector resolution, then upward force equal to downward force, and we are getting the answers. But there are some theorems. If an object is under equilibrium with three forces, you can use triangle law and reciprocal of triangle law, and Lamy, in singular we are calling it as Lamy law. In English, I think it's Lam's law, right? In English, I think it's Lam's law. Now, I will give a small brief about that. 9 o'clock. Okay, we'll take a break and come put some reply. Who want a break? Reply, we'll take a break and discuss the story. We'll take a break and we'll discuss the story. Put some reply, everyone. We'll take a break. We'll take a break and we'll reply. We'll take a break and we'll reply. Put some reply. We'll take a break and we'll reply. So we'll take a break and we'll reply. We'll study. Next story. We'll take a break. We'll take a break, nee. We'll take a break. Time is 8:50. Come at 19. Drink something. Eat something. Come at 19. 19 to 10:30. Sometimes I don't know 11 also. If I do questions, don't know. Right? Take your break and come. Drink something. Eat something and come. Take your break and come. All right, okay. And now time is 19, then till 10:30, sometimes 11 o'clock, I don't know at what time I will stop the class. And now see, this is the idea. Now I told you, the first thing is, if any of you faced your first term test, if you experienced FWC paper, you don't come to a conclusion that when your marks is too much low, you don't come to a conclusion that you are weak. That's wrong, because generally in that given time doing an FWC paper is not easy, right? If someone is scoring more than 60 means, right, it's something extremely big thing, okay, right? Just because you could not score at least 50, you don't come to a conclusion that you are not good or you are weak. Don't think like that. First term test ni, many people come to the right track 4 months before the exam, right? Some of you, to be honestly, even myself, I also started coming to the track after 1 year later. After one year 3 months later only, I also realized the things and how the real thing happening, what's really happening in the papers, what's really happening in every subject. Therefore, with your first term test marks, some people they score good marks, that's okay. Just because your marks is low or something, please, you don't fall down. Now, I told you already I told you that. I told you work more, work hard, because in my classes, I don't know when you compare with other online classes. I don't know you are going for the any other online or physical physics class. I don't know. And also I don't know that when you compare with other subjects, chemistry, combined maths, biology, right? I think that I think we are doing a huge amount of work in our classes, right? So we are doing a huge amount of work in our classes. You all agree? Upcoming days, I told you February onwards, I will increase the amount of questions we discuss in the class. I will increase, right? We are not wasting our time. We are not entertaining. I am not roughly explaining and I am not finishing. When I explain the theory also, I go in deep. When I discuss questions, I don't discuss easy questions. I discuss overall all the questions. I don't discuss in the theory class the past paper questions. I don't discuss, right? Dedicated. There's a day in our paper class. On that day only, I am discussing past paper questions, right? In the theory classes, I don't discuss past papers. Past paper class, even when I discuss past papers also, I don't discuss 1 and 2 past paper MCQs. I go from entire story. From 1990 to 2020 till now, we are doing past papers. Kinematics, we completely finished all the past paper MCQs. Units and dimensions, finished, right? So it's a promise that I'll give in my end, all the past papers, 1992, 2020, 5A level. Not only MCQ, but also essay, right? Everything, but also successes. Measuring instrument, go and check all the measuring instrument sections came from vernier caliper, micrometer, gauge, spirometer. That day itself, there were only five questions. And additionally, I did one of the FWC stocks also, right? Therefore, I'm doing everything. I have a small plan, right? My small plan is, not only you, this 26 batch, I am putting my 100% effort, and then my next batch 27, because personally, you know that I am also result oriented person, right? To keep students, I don't do things. Okay, students, if most students are coming to my class, really better, really good. Even if I'm having a crowd who is capable enough to get A's, that's my target. Really, I am result oriented person. Somehow I also want to train you all, and somehow I want to bring you all to A result, at least B, the worst scenario. At least there must be around 40% at least A, the remaining B. It's not easy as you think. That is also my goal. So in my end, you know that already we are doing 3 classes already per week. I'm okay, already I taken 3 classes from you. Additionally, I'm putting extra classes. When exam come closer also, you realize that, because sometimes there is my own way, but because most of you told to complete that measuring instrument sections and all, I have conducted. Even I was very sick also, right? I was doing some class and I covered some sections. For sick leave also, I have covered some sections, but 1 2 MCQs came for your exam. Just leave it. It's okay. It's okay, right? I have a small plan. This plan now still the thing is, remember, mechanics, you haven't obtained the 100% exposure. I feel like linear motion, vertical motion, projectile motion, motion graphs questions, you were able to do well in your exams. But especially Newton laws and forces, force equilibrium stories, you could not perform well. Because in our class also, past papers also, we haven't completed force equilibrium sections. Right? We haven't discussed any part. We just started force, Newton laws and forces one day, I think, if you can remember. Then we have to continue the remaining past paper MCQ discussions. And then we're going to do all the mechanics past paper essay questions. Statistic. After doing those, you will obtain a good exposure. Not only that, right? In our target papers, we only wrote one target paper, two target papers. Right? Tomorrow only we're discussing target paper 2. Right? In that case also, after 2-3 months later, you will get a good exposure. Parallelly, I have a small plan. Okay, I don't take that much of time. Parallelly, I have a small plan that plan is I am also planning to obtain a good result from your batch. Therefore, if I'm not commonly taking everyone, right? I just see that based on students' performance. I'm also, because based on my available time, I'm planning lots of things, but it takes some time to execute them one by one, right? Not now in a 1 month or time period. I thought of doing something like this, because forcing everyone to do same thing, everyone don't do, no matter in a class also. Now I'm telling that everyone to do this question and send me as a homework, but everyone, they don't follow, because they may have their own limits. They think like not necessary, and they sometimes they skip. But some students are there, whatever I tell, they follow, right? Because I'm planning to take a set of students based on your performance, based on your marks. Because I want some students who have that curiosity, that willingness, right? Who are ready to work unconditionally to give some. I'm going to take a people among you, and I'm going to give us some kind of a special practice for the people, right? If I give that practice, everyone don't follow, right? Only for the people who are dedicated and who are scoring, not only scoring, but also dedicated, doing everything. Sometimes marks is not coming. Marks not coming, but I'm dedicated. I'm working hard. That people, right? I will find a way to evaluate them, and I will keep a separate group of them, men. If you don't come to a misunderstanding that in case that if I didn't consider everyone, this is something beyond I'm doing. A small story to giving additional work, and I thought of give some stories there. Not a theory class. Theory class, the way I'm doing, same way theory class, same past paper, same model paper. Everything is same. But people who are scoring good marks, who I see every day coming to the classes and every day writing the papers, marks improving 20, 25, 30. Those people I will put into that group, and people who follow what I say. The most important thing is want to follow what I say, right? You want to follow your own stories, and parallelly you want to follow my stories also. Then I will I will take a small team among you, and I will give a kind of special practice for them. Special practice. Better if everyone can come to that story. But I know that most of you, if they can come, it's better, right? That story also there. And also I told you, I will put some night sessions. We'll do night sessions. We'll do questions, right? Don't worry. It's all about exposing to papers. Target paper class started. Only second paper only we finished. Every week you are writing paper, where after 2-3 months later you will see the progress. Okay, so I'm doing everything possible in my end, right? Okay, everything possible in my end I'm doing. Okay, right? Okay, time is 9:18. We have maximum around half an hour. Okay, we'll do next story. Next story. Okay, then next theory. Okay, right, right. Next story. Listen, triangle law of story. Listen, next theory. Next theory is story. Now condition for, okay, that's done the last theory, triangle law of equilibrium for 3 coplanar forces. This idea, triangle law. Now before talking about triangle law, listen very, very carefully. We'll talk about vectors. When we were learning vectors, if you can remember, we talked about polygon law, right? When do we use polygon law? If we want to find the resultant of more than 2 vectors, we can use polygon law. Right? Can you remember the polygon law? First of all, I will brief something about polygon law, when I will come to triangle law. Then it will be easy to talk about reciprocal of triangle law. These stories I am just explaining, not coming that level. This is idea, polygon law. Polygon law stories. Polygon law. If you have doubts, put it in the WhatsApp, okay? Polygon law. I'll find a way, okay? I will give you a plan to improve your MCQ marks also, right? But I want to know you are whether really doing properly that MCQ short note point book. Not only the writing, but also every day I'm referring. That's also important. Polygon law. Okay. Polygon law, vectors. Even when I was explaining polygon laws, if you can remember, right, I taken 3 forces and I explained the polygon law, if you can remember. Okay. Now, once again, I brief it. Polygon law means, let's say, when there's an object. Now, there are 3 forces acting on the object. One force is vector A. Polygon law is vector story. One force is vector A. Other force is vector B, like this direction. The third force may be vector C. What is polygon law? If you can represent these 3 vectors as adjacent sides of a polygon, you can start from any of the vector. If I draw vector A, from the point where you finish drawing the first vector, you can start drawing second vector. You can start drawing second vector means vector B or vector C. If I take vector B, from the point where we finish drawing a second vector, you can start drawing third vector, vector C. Right? So the initial point was here, final point was here. I told you, but one condition is there. When you're drawing the vectors, they must flow in one direction. Arrows must flow in one direction. That story we know that. After completing drawing the vectors, if the forces acting on the object, the vectors, when you connect initial point and final point together, that will be the resultant of these 3 vectors. That will be the result of these 3 vectors. If not, that will be the resultant force of these 3 vectors. In the question discussion, I told you that what if this initial point, this final point again coincide with the initial point? What if? Now, this story very clear that initial point is here, final point is here. Those 2 points are not coinciding. Those 2 points are not meeting. Therefore, there is a resultant vector, there's a resultant force for these 3 forces. In case, I told this idea, in case if this final point is coinciding with initial point, in case if the final point is coinciding with initial point, for an example, okay? For an example, I'm telling you, for an example, vector simply, this story we learned. Vector simply, vector simple B. This final point, vector C, when I draw the vector simple C, vector C, okay? Final point and initial point are coinciding, same point. In that case, what is the resultant of these 3 vectors? When you are following the polygon law, if the final point and initial point are coinciding, what can you say about the resultant force, resultant vector? I taught you in the classes, resultant is 0. 0. This triangle law is the polygon law. Now they are talking about triangle law story in this question. The triangle law means this story, this application. What is the story? If 3 vectors, right? What is story? When there are 3 vectors, if the resultant is 0, initial point and final point are same. Then it's going to be a kind of triangle. When you mark 3 forces, if the resultant of these 3 forces is 0, then initial point and final point are same. And now this will go with this idea put in your mind. If I go to this triangle law of equilibrium for 3 coplanar forces, they are telling what? Read the story. They are telling what? If 3 coplanar forces acting at a point are in equilibrium, if 3 coplanar forces acting at a point are in equilibrium, this story. When 3 forces acting at a point, acting on an object, are in equilibrium means what? Resultant of those 3 forces 0. Clearly? If 3 forces acting at a point are in equilibrium, that means resultant of those 3 forces is 0. They can be represented in magnitude and direction by the 3 sides of a triangle. Take it in order. This story. If resultant was 0, it will form a kind of triangle. It's a vector story. If there are 3 forces acting on an object are in equilibrium, the resultant force of those 3 forces 0, Then you can represent those three forces as a triangle. Same story. Same story. Right? Same story. Okay. For example, this idea put in your mind, this idea. If your doubts, ask. Theory finished. Theory finished. Okay. Okay. Now there are Now there are three forces acting on a point, acting on the object, whatever. Right? One force is capital P, capital Q, capital R. Listen very carefully. There are three forces. One force is capital P. Okay, upcoming days after I send the short note point book, I prepare a short note. Then I will send a kind of workbook monthly. I also have plans. I also want to put into the right track. Right, in that workbook, there is a kind of day planner. Right? So I will send the next workbook, the next day planner, if you really follow the day planner properly only. Likewise, some stories are there. Okay? Okay. Don't worry, okay? Don't worry and don't give up. That's what I can tell. If you start giving up, then can't do the story. Don't give up. Suddenly you can't become a doctor, right? Do you think suddenly they give this 10 million of worth money directly into your hand? All right. Therefore, don't give up and keep on working. Keep on working. That's what I can tell. Anyone have the patient will get it. That's my logic. Right? There are three forces acting on the object or acting at this point, capital or something. Okay. There are three forces. This force is capital P, capital Q, and capital R. Alright? And they have given the angles. This angle is alpha. This angle is beta. Listen. This angle is beta. This angle is gamma. Right? Gamma. Now, if this object at this point is under equilibrium with these three forces, what can you say about the resultant of these three forces? Resultant of PQR must be 0. Resultant of PQR must be 0. Resultant of these three forces 0 means when you try to draw the polygon using these three forces, it will form a triangle. The resultant of these three forces is 0 means when you try to draw a polygon, it will create a triangle. Why? Final point and initial point will coincide each other. That is the logic. If you draw the triangle, you can start from any of the vector. I can start from vector P, if not vector R, it's up to you. I'll start to draw the triangle from vector P. Vector P. Vector P. Vector P. From the point I finish drawing this force P, I'll start drawing Q force acceleration, Q force. From the point I finish drawing force P, I start drawing force Q. From the point I finish drawing force Q, when you draw the force R. From the point you finish drawing force Q, you draw the force R. The final point of R and initial point of P going to be coincide. It creates a triangle. This is we call as triangle law. Nothing new story. Nothing new story. Right? Summary is very simple. Remember, if three forces, an object or a point is under equilibrium with three forces, result is 0. Therefore, when you draw the polygon, it creates a triangle. That's it. That's it. That's it. Then you can mark this angle. This angle is P. This angle Q. This angle is gamma. This angle is gamma. P. This angle is gamma. This angle gamma, right? And then PQ R angle, right? This horizontal line. This entire angle is beta. This is 90. This angle must be how much? This entire angle beta. This 90 means this angle is how much? This angle must be how much? It must be beta minus 90. Beta minus 90. This angle is beta minus 90. Beta minus 90. Right? That's it. This is the idea. So draw this triangle in the given space. That is the idea. If you want, you can draw the stories also. Right? Okay, finish, put a reply. The reciprocal story. Finish, put a reply, the reciprocal story, then I am doing questions more. Okay, reciprocal story, then I am doing questions more. Now I am wondering, okay, if I talk, I keep on talking, you know me. That's my way. When I talk, I keep on talking. That's my way. Finish, put a reply. Finish, put a reply. Simple story, okay? Very simple story. Learn everything properly. Don't worry. Not only theory class. I will have lots of plans. Trust me. Okay? Right now only we are in the track. We started paper class. Now we are giving big exams. It's a big story. Big story. Right? Online I have the freedom. I can decide the time and I can do. Right? Okay? Don't worry. First term marks is always like that only. My first term marks was how much? Now always you don't think that I am comparing myself. Every time sir is comparing sir self. Sir is not us. We are not user. I understand. I understand. Finish, put up the reply, done, put a reply, done. Because the most, why I am worrying is based on this term test marks. What happened in my school, I told you many times, most of students who got 9 is also, they fed up and they give up. I'm really worrying that my students are going to go hell in that way. I don't be like that. Okay? I told you this will happen, right? Finish with a reply. Then next story is reciprocal of triangle law. The next story is reciprocal of triangle law, then questions. The Lamy law also I'm telling. The next story. Finish the reply because I don't know. Normally I ask, raise your hands, and based on that only I will go to next theory. Right? Night question discussion. Everything I will do. I will give a work plan. I'll give a workbook. Right? Preparing. Take some time to prepare. That's the problem. Want to prepare everything properly. Even when I'm providing a tute also, your batch. I think the first month tutes are not that much cold. Only the questions were there. Now you can check with, not telling I am the best, but even the tute also you can see, right? Right? Okay. Okay. Done. The next story. A reciprocal of triangle law. What is reciprocal of triangle law? Triangle law says what? Triangle law says that if the three forces are equilibrium, that means resultant force 0 means you can represent these three forces as a triangle. Once again, triangle law says what? If three forces are under equilibrium, if not resultant is 0, you can represent these three forces as three sides of a triangle. What is reciprocal of triangle law? If you can represent three forces as a triangle, if you can represent three forces as a triangle, those three forces are under equilibrium. If not resultant of those three forces, 0. The reciprocal. The reciprocal is what? Reciprocal is if there are three forces and if you can represent those three forces as a triangle, that means resultant of those three forces is 0. That means those three forces are under equilibrium. That is the idea. You understand? What is triangle law? If three forces are under equilibrium, they can represent as three sides of a triangle. Reciprocal, if three forces can represent as three sides of a triangle, those three forces are under equilibrium. Very simple logic. Very simple logic. These things are not that much important. Therefore, I mentioned if three forces acting at a point can be represented in a magnitude direction by the sides of a triangle, taken in order, then those forces are in equilibrium. That story is not that much relevant. Lamy law. Write down everyone under Lamy law. Normally we tell Lamy law only. Lamb's law, Lamy law, whatever. Write down. If three concurrent forces, write down there. Different color pen, not red color pen, different color pen. if three concurrent forces, if three concurrent forces, if three concurrent forces acting on a body, acting on a body, acting on a body, kept in equilibrium, kept in equilibrium, kept in equilibrium, comma, kept in equilibrium, comma, kept in equilibrium, comma, then each force is proportional to the, then each force is proportional to the, then each force is proportional to the, then each force is proportional to the sine of sine of sine of sine of angle between the other two forces, angle between the other two forces, angle between the other two forces, and the constant of proportionality is same, and the constant of proportionality is same. It's not a big deal, okay? And the constant of proportionality is same. Look here. Now allow me to say a beautiful story. Suppose if there are three forces under equilibrium, that means what? Resultant of these three forces is zero. If there are three inclined forces under equilibrium, that means resultant of these three forces is zero. We can write down like this. Remember, capital P force, right? Take one of the forces, capital P. Capital P over the sine value of the angle between other two forces. When you take capital P over, what are the other two forces? Q and R. Q and R. The sine value of angle between other two forces, alpha, sine alpha. Right? That is equal to the other force. It can be Q or it can be R. Let's say Q. Q over the sine value of angle between other two forces. If you take Q, the other two forces is going to be R and P. The sine value of angle between other two forces, sine beta, must be equal to the next force R, capital R over, what is the other two forces? If you take capital R, other two forces going to be Q and P. The sine value of angle between other two forces, gamma. Sine gamma, all is a constant. If you are doing combined maths, you learn sine law. This idea, you learn sine law, combined maths. But by people don't want to know the story. Roughly remember, if you know these angles, right? Now see, now this type of question, how we solved previously. If there are three forces, right? We have done, today in the beginning, we have done this type of question. Right? There were two strings. This is 100 something, I can't remember. T1, T2. Right? If you know these angles, 90. This angle, if you know this angle, you don't want to do the vector dissolution. You don't want to do the T2 cos theta 1, sin theta 1. You don't want to resolve T1 something, T2 something. You don't want to resolve anything. If you know the angles, if you can find these angles, they are telling T2 over the sine this angle, T1 over sine this angle, 100 over sine 90. You can apply this story. I will show you by doing questions. Right? I will do that previous question in this method also. Lamy law, Lamy's theorem. Is the idea. And then what you can do? You can consider these two. If you consider these two, you can write down P over sine alpha equals what? P over sine alpha equals Q over sine beta. I will show you how to apply Lamy's theorem into a question. I will show you. And also I will show you how to apply triangle law into a story. I will show you by doing questions, don't worry. But you decide what is the best way for you. Q over sine beta. Other one is in one equation. Likewise, when you consider these two, Q over sine beta, Q over sine beta you can must be equal to R over sine alpha, R over sine gamma. If not, one can consider this one and this one. It's up to you. P over sine alpha or P over sine alpha must be equal to R over sine gamma. Right? Likewise, you can equal two terms and you can obtain some equations. This tutorial also write down in the given space, theory finished. Force equilibrium, without skipping any single theory, everything I explained properly. Now want to do the past paper sections, want to do tutor questions, right? Want to tutor questions. The last one is type of equilibrium, stable, unstable and neutral. Small theory part, stable, unstable, neutral, small theory part. Right? This is the main core. Finished. Everything is finished. I talked about everything properly, right? I discussed everything clearly. Now questions only. Now stable, unstable, neutral. Just read the story. Take it into read the story. Unstable, stable, neutral. Read the story. Now I don't need that much of time. This idea, okay? This idea. Now we know that unstable. What will happen? When you provide, if the object is at a point somewhere here, point capital E. When you apply small displacement, what will happen? Will this object come back to point capital E? When you apply small displacement, this object will never come back to initial point. Therefore, this type of equilibrium unstable. This type of thing unstable. Unstable equilibrium. Right? It will never come back to initial point. Suppose the object is somewhere point capital B here. Even you provide a small displacement, this object will slightly move this and again coming back to same position. Even you apply small displacement to this object, it will slightly move and again coming back to same position. When the object is at a position like point capital B, we call it a stable equilibrium. Stable. Now, suppose the object is somewhere here, point capital C. When you apply small displacement, this object will move another point. But again, at that point, object will be under equilibrium. If we move by small displacement, it will move another point. Never come back to initial point. But in that another point, it will stay under equilibrium. It's neutral equilibrium, just explained. That is enough. That's story enough, theory finished. Center of gravity idea, I don't do now, later we'll discuss that story. Questions. Genuinely hands up. Now properly when I compare what I have done so far. Unit 3 oscillation and waves, I start from optics roughly. Last Monday, I gave a small introduction. Actually, I haven't started any theory yet and optics. When you go back to the past in our mechanics, the number one lesson is mechanics. Mechanics, I talked about linear motion, vertical, projectile, relative motion graphs, then Newton laws and forces, then then linear momentum, conservation of linear momentum, work energy power, conservation of energy stories. Then we talked about torque, very important story, torque, a couple of forces, moment of a torque. Then we talked about force equilibrium. Simple. Everything we learned, right? Put in your theory properly, okay? Now the amount of the work that we do in our class, see currently, let's say now you will understand. Nowadays we are going like this. Upcoming days we will do like this. Okay, right? Normally I am doing lots of works. Don't worry. Okay? Don't worry. Reply everyone. Everything we learned regarding force equilibrium and everything is crystal clear. Put a reply in the chat. Say everything is very clear, sir. Everything is very clear. Put a reply. Everything is very clear. Put a reply everyone. Everything is very clear. Put a reply. Reply everyone. Everything is very clear. Everything is very clear. Put a reply. Everything is very clear. Put a reply. Very clear. Put a reply. Put reply everyone. Reply everyone. Reply everyone. All clear? Right, okay. Work with me unconditionally. No, what we call in English, no compromise there. What we call no negotiations, right? No negotiation. Okay, right. Questions. We are going back to some questions. Tude questions finished, right? Tude questions now. No break. Class will stop at 10:30. Sometimes 11. I don't know. I don't know what time it will stop. I don't know. Right? Okay. Everything discussed. Discussed everything. Questions. Start doing question number. Then we discussed about 18 done. 18, 21, 22, 23, 25 discussed. 24 we can do. 24 we can do. Before 24, there's a big story. We'll go to question number 13. Question number 13. 13 idea. 13, most of the MCQ also is the idea, this logic came 13. Many can't, you try to do the question, but I don't give that much of time. I will do it. 13. Neglecting friction. Find the minimum. Okay, 13. Then 13, 14. 13, 14. 16, 15. 15 is a super question. 15 is super question. Huh? 13, 14, 16, 15. Right? 13, 14. 16, 15. Starting them. Right, starting them. I will teach you how to apply Lami's theorem, triangle law stories. I will teach you. 13. Starting 13. 13 idea. 13. Draw large diagram. Neglecting friction, find the minimum force capital F required to lift a uniform circular disc of mass, simple m and radius capital R, up a step of height simple h. That diagram, very important. Upcoming papers also you can see MCQs from the story. 13 idea. 13. This diagram, yeah, shape. Okay. Right, start doing. First of all, learn. Now, these tricky things, sometimes even we also don't get the idea. In single, if I talk, පොර වගේ අපි ගණන් හැදුවට පළවෙනි සැරේට හදන කෙනෙක්ට ඕක කරන්න බෑ. Right? මගේ point of view එකනේ. according to my point of view. Sometimes නේ ඒක ඇත්තටම කරන්න අමාරුයි ඇත්තටම. ඒකෙම ලේසි නැහැ ඒක. සමහරක් වෙලාවට ඔයාලා හිතනවා just I'm telling, I can convert in English and tell, but සමහරක් වෙලාවට හිතනවා ගොඩාක් ළම හිතන්නේ දැන් අපි ඇවිල්ලත් එක පාරටම හිතනවා එක පාරටම උත්තර ගන්නවා බලපු ගමම්ම තප්පරයක්වත් යන්නේ නැහැ සර්ට අදහස් අයිඩියා කෙනවා එහෙම දෙයක් නැහැ ඇත්තටම එහෙම නෙවෙයි වෙන්නේ අපි වුණත් ඔය ප්‍රශ්න to be honestly මම නම් කියන මං ගැන ඇත්තටම මම වුණත් සෑහෙන්න ඔය ප්‍රශ්න එක්ස්පෝස් වෙලා තියෙනවා ඒ එක්ස්පෝෂර් එක තමයි මට ඔය ලෙවල් එකට ප්‍රශ්න කරන්න පුළුවන් අනිවාර්යයෙන්ම මෙතන ඉන්න ඕන ළමෙක්ට එක්ස්පෝෂර් එක ගන්න පුළුවන් කාලය හොඳටම තියෙනවා හරියටම වැඩේ කරන කෙනාට අනිවාර්යයෙන්ම ගොඩ යන්න පුළුවන් එක පාර්ටම හැමෝටම බලපු ගමම උත්තර ඉන්නේ නැහැ ප්‍රශ්න පේන්නේ නැහැ කොහොමද උත්තර ගන්න කියලා මැවිලා පේන්නේ නැහැ ප්‍රශ්න බැලුවාම මේ වගේ ප්‍රශ්නයක් හදනවා ඊළඟට මේ වගේ ප්‍රශ්නයක් තවත් පොතක තියෙනවා එතකොට කලින් මේ වගේ ප්‍රශ්නයක් හදපු හින්දා එතන අයිඩියා ටිකක් එනවා අර එහෙම පොඩ එකතු වෙලා තමයි පීකට යන්නේ Okay, that's it. But by looking at the questions, now some people think like, so you are getting the answer very soon. By looking at the question, by reading the question, without spending 1 second, you know what to be done and how to get the answer. But we don't get such ideas. Are we weak? Is that mean are we weak? Not only you, but also even us also. Same story. Some questions, even when I read also, I don't get the idea, to be honest. With the exposure. How many times I have done these questions, think practically. Because of that practice only, to be honestly, I am doing these questions. So that's why I'm telling every day expose. Okay? Write this idea, okay, without wasting time, without talking any gossip. 9:50, 11 o'clock, 10:30, sometimes 11 o'clock. Okay? Keep on doing. We have 4 questions. Right. A given data. Okay. Right. Okay. Now they mentioned what is the minimum capital F force? Neglecting friction. Find the minimum force required to lift a uniform circular disc of mass simple limb, radius capital R. Given data simple limb capital R. Height simple step of height simple h. Given data mRh. Given data mRh. What is m? The mass of the disc is simple limb. If I mark the forces on the disc, the weight is simple mg. What are the other forces acting on the disc? Tell me. The normal reaction force acting on the disc, because there's a contact between the horizontal ground and the disc. Normal reaction force capital R. Capital R. Other than mg and r, tell me what are the other forces? Now you are applying a force on the disc through the center in the right side direction. Why you are applying that force capital F? To move the disc on the top of the step. You want to move the disc around the step. So somehow you want to lift the disc from the step. So you want to rotate the disc from the step. The force that you applied is what? That is capital F. This force capital F. Right? Capital F force. So you want to find actually capital F only in terms of simple limb and capital R and simple H. This gap is simple H. This gap simple H. Right? Right? I will tell the criteria, okay? Right? I'm selecting a small set of students. Even I'm telling you after class finishes, once again read to and send me. Likewise, I will give a small track, okay? And every small thing you are following without following the deadlines, right? I will tell you the story. Because if you become a doctor, then I'm also getting kind of benefit, right? If you become a doctor, I'm also getting kind of benefit, to be honestly, right? H. The normal reaction force I put as R1 something. Tell me what is the distance from this point to this point? The distance from the center to a point on the circumference, that is going to be the radius capital R. Radius capital R. Okay. Now if I mark the forces on the disc, we know weight, normal reaction force capital R1, the force you apply capital F. Are these only force acting on the disc? No, right? Because disc is in contact with the point, this H point capital O. Then if you mark the normal reaction force acting on the disc at point capital O, we know whenever two objects are in contact with each other, there are normal reaction forces perpendicular to contact point. Now the normal reaction force acting on the disc at point capital O is in the radial direction, this direction, right? If you don't know, that's also put in a short note point book. Look here. For a circle, if you draw tangent line, look here. Some stories, if you don't know, put a short note point. Okay. Let's say now an object is in contact at this point. Right? Remember, draw tangent line. Right? The object, always the normal reaction force. Right? If an object is in contact at this point, any point on the circumference of the circle, the normal reaction force always acting this radially, passing to the center. the normal reaction force always acting radially, passing to the center, right? That story. Radially. Normal reaction force acting radially, passing to the center. That point put in your mind, okay? If I mark the normal reaction force acting on the disk at point capital O, the normal reaction force, let's take it as R2. This force is going to be capital R2. Capital R2. Right? Now, just think that when the moment you barely, right? What's your target? Your target is you want to lift the disk about point capital O. Somehow you want to move the disk around point capital O. You want to lift it around, you want to lift it from that step. When the moment, now you are applying a force and you are producing kind of torque and you are lifting the disk, when the moment this disk started lifting, when the moment this disk is started lifting, what will happen for the contact between disk and the horizontal ground? No contact. When the moment circular disk started lifting from the ground, there is no contact between the disk and the ground. When the normal reaction force acting on the disk is zero. Right, Kelvin, write down important story. Right, Kelvin, important, write down. When the moment disk started lifting from the ground. When the moment disk started lifting from the ground. When the moment disk started lifting from the ground. When the moment disk started lifting from the ground, comma, there is no contact between disk and the ground. There is no contact between disk and the ground. There is no contact between disk and the ground. There is no contact between disk and the ground. There is no contact between disk and the ground. Right? Therefore, the normal reaction force acting on the disk by the ground becomes zero. Therefore, the normal reaction force acting on the disk by the ground becomes zero. Therefore, the normal reaction force acting on the disk by the ground becomes zero. This capital R1 becomes zero. Right? Now think, now some people can argue different ways. When the moment disk started to lift, think disk is under equilibrium. When the moment disk started to lift, think disk is under equilibrium. Disk is under equilibrium. Disk is under equilibrium. Right? And now think disk is under equilibrium. When the moment started to lift, disk is under equilibrium. Disk is under equilibrium. Resultant force acting on the disk must be zero. Resultant torque at any point on the disk is zero. What I want to find actually? I want to find, they are asking capital F. They are asking capital F in terms of what? Capital F in terms of what? Capital F in terms of simple M. I want to find capital F in terms of simple M, simple G, capital R and simple H. Right? If I do the session in the Zoom session better, then I can ask some cross questions. Right? This point is point capital O1 something. This is point capital A something. Point capital A, point capital O, point capital, this point is point capital B something. Right angle triangle. Now then, sir, if I want to find capital F, we know first option is we can take right resultant force 0 and we can do something. You can consider resultant vertical force 0, upward force equal to downward force, so you can do something. If not, we can take resultant horizontal force 0, right side force must be equal to left side force. If not, what we have done, what we do, we take a point and resultant torque around that point is 0. We'll do that story. Right? If you are taking the torque, now if you say now when the moment this started to move, R1 is 0. Then R1 does not produce any torque, R1 0. Then there are only three forces, mg, R2, capital F. Right? Disk is under equilibrium also. Disk is under equilibrium also. If you take the torque around point capital A, my advice is, if you take torque around point capital A, what can we say about the resultant torque around point capital A? 0. If you consider the equilibrium, if you consider point capital A, if you take the torque, resultant torque around point capital A must be 0. right? That logic. Right, resultant torque must be 0. Then if you take the torque around point capital E, take torque around point capital E, resultant torque around point capital E must be 0. The problem is finding the distances. Keep on doing. Then if you take the torque around point capital E, now there are three forces, F, mg and R2. R1 is 0. Then if you take torque around point capital E, R2 is passing through point capital E. R2 does not produce any torque around point capital E. Then only F and mg. Only F and mg. Get the answer. Only F and mg get the answer. Only F and mg get the answer. Get the answer, everyone. Get the answer. 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 Right? Get the answer. Right? I only draw these two forces F and mg for your understanding, not important, but for your understanding. You guys keep on trying the question. I can't give that much of time. If I do that story for your understanding, is the diagram. Very simple story. Different types of questions. Get the exposure. If you could not get the answer, don't worry. Don't come to judgment. Now, if you have second term, this will work. Okay. Right. Okay. This point is point capital E. This point capital B. The forces, the weight and capital F. This is weight. The weight force mg. This is the capital F force, horizontal force. Capital F, horizontal force. Right? You want to find capital F. Now this is radius. Point O2 is radius capital R. Then tell me what is this gap? This gap is how much? This gap. Point O to this point is radius. Point O to a point on the circumference, vertical distance from point O to a point on the circumference is the radius. This is radius. This gap is simple h. Radius capital R. This gap simple h. What can you say about this gap? This gap is how much? Capital R. This is simple h means R minus h. OB. This gap is how much? R minus h. That is the only tricky thing. R minus h. Pythagoras, right angle triangle, you need this distance, okay? Then tell me what is this gap? This gap is R minus h means A to this gap is how much? Perpendicular distance to capital F force from point A. This gap how much? That is also R minus h. This is the only tricky thing. Pythagoras, what is this gap? This gap x. We'll find the x in terms of R and h. Pythagoras theorem, hypotenuse R, this height is R minus h. Pythagoras theorem, Pytho. If you apply Pytho, capital R squared must be equal to capital R minus simple h whole squared plus simple x squared. Plus simple x squared. Pythagoras. All maths. R squared. Expand the bracket. R squared minus 2 capital RH plus simple h squared. Plus simple x squared. Pythagoras theorem. Right? Then substitute simple x squared. Move in R squared minus 3. If you move this one, R squared minus capital R squared. Minus 2RH if you move left side. Plus 2RH. Plus 2RH. Plus h squared if you move left side. Minus h squared must be equal to x squared. The very first time these seem like very difficult. So how you are getting this idea? I never imagined we can get these links like this. That's how you think in the beginning. Every time first experience is very nice, you think first experience is like that only. But you just go and check the past paper, same stories asking again and again. Let's go into the past papers. Substitute x k hat, then x k hat is x is how much? X is how much? Then 2rh minus h k hat. So you can take h as common factor. Then r squared minus r squared cancel out. 2rh minus h k hat. H common factor, take h common factor. 2 capital R minus simple h whole root. X is this much. Then sir, now what we want to find, okay, you found some distances. What do you want to find? What do you want to find? What do you want to find? So they are asking us to find capital F in terms of MGRH. Right? When you take the torque around point, when you are taking the torque around point capital E, when you are taking torque around point capital E, resultant torque around point capital E is 0. Why? System is under equilibrium. Then there are only two forces producing torque. One is the capital F force producing clockwise torque around point capital E. Other one is mg is producing anti-clockwise torque around point capital E. Clockwise torque must be equal to anti-clockwise torque, whatever. Then this story, if I write here, so you can write down what? You can write down clockwise torque produced by capital F, F into perpendicular distance to capital F force from point capital E. Capital F is a horizontal force. From point capital, if you draw a perpendicular line, that's going to be a vertical line. That is how much? Vertical line from point capital A to F is what? R minus H. Clockwise torques are positive. I want to find capital F only, plus capital F. Right, plus capital F into R minus H. R minus H must be equal to, clockwise torque. Then mg creates anti-clockwise torque around point capital E, minus mg into perpendicular distance to mg force from point capital E. Mg is a vertical force. If you draw a perpendicular line to that vertical force from point capital E, that is basically x. That is basically horizontal distance. Perpendicular distance to the mg force from point A is horizontal distance, simple x. Simple x how much? H. This story. H. 2 capital R minus H. 2 capital R minus H whole root. This must be equal to 0. This must be equal to 0. Likewise, get the answer. Get the answer. Then you want to substitute capital F. Move this one to the right side. Then capital F into R minus H. If you simplify properly, capital F, okay, capital F into R minus simple H must be equal to, next Thursday we are starting hydrostatics, mg H2 capital R minus simple H whole root. Okay, don't worry, I will start some programs, okay, for sure. Give me some time. I need 1 month of time, right, to fix everything properly and evaluate. I will evaluate and select some students, right, because I want to work with a team. H2 capital R who should follow what I say properly, right? I will tell you one story now. If you have money, look here. Now recently, one girl came. She got 2 A's and 1 B. Is the answer for the F in terms of MGRH. Once again redo it, okay? Now she got 2 A's and 1 B, and unfortunately she could not go to medical faculties. She got 2 A's and 1 B. She could not go to medical faculties. I told her to redo second shy. I told you it's okay to second shy, because I told you most of them enter into medical faculties. They are going with third shy actually. Around 60 to 65% people enter into medical faculties from their second or third shy. 35% only entering to the medical faculties in their first shy. I told her that okay, you try definitely once again. Already your first result is 2A 1B, for sure, trust me. Second result will be definitely you can go for rank also. You can put a big district rank. Then she said that no sir, I'm very tired of studying, but she followed everything what I said. Right? She followed everything what I said, right? Then no sir, it's okay sir, now I'm planning to migrate. That means she is doing her medical that degree in Belarus, right? Belarus. right? And we know mostly people who are going abroad for the medical degrees. They are going to Russia, Belarus, like some countries, some UK. Right now, Belarus. Then I asked that how about the cost and how about the expenses? Right, then we know in medical degrees 6-year program, right? Engineering degrees 4-year program. Even we say 4 years in Sri Lanka, 4 years means even my degree completed because of pandemic issue, something comes, right? I should have completed my degree in 4 years because of pandemic, that story, this story, corona and all. I think we took around 5 years something, 5 plus something. Then if you are doing now some stories plus and minus, right? She told that it's about 60-year degree in that country, normally 6 years only, right? Then she told that I asked that how about the cost and all. Then she said, sir, now a total cost, only the tuition, only the fees, only the fees, talking about the fees only, I think, not about the other expenses, not about her what expenses, only the fees for the 6 years. She said that approximately 180 lakhs, 180 lakhs, right, for the 6 years, all the tuition fees and all. Then I said that then how, then she is not, as per my understanding, she is not coming from a very wealthy family. Suddenly putting 200 lakhs to that story, it's not easy. For some people, they have the potential. Some of you also might have the potential, right? Okay, I heard a story. I heard someone told, okay, that story, okay, that guy told me, I think some of that guy's relatives also here. That guy told you, one student, okay, he told one day, sir, my father told, he told, okay, I will come to that story again. So my father told, if I get 3 years and if I get into the Colombo medical faculty, my father told, my father will buy and give me a Benz car, right? Okay. Okay, one story. Okay, I'll come back to the story. Generally, most of us, we can't afford that story, that money. Then I asked that how are you going to manage expenses? Then she told that, sir, we don't want to pay the entire money as bulk. We can break into some and we can periodically we can pay. Once in 6 months only we have to do the payments. Right? Then the first payment is 30 lakhs. First payment is 30 lakhs and every semester they are charging 12 lakhs something. Every semester they are charging 12 lakhs. Even 12 lakhs, 8 lakhs we can pay in the beginning and remaining 4 lakhs we can partially monthly we can give to the university, right? Then how are we have you fixed any part-time job there? Because even you go to abroad also you can't find a very big nice part-time job. You also want to clean the table. If you're seeking a part-time job, you want to clean the table or you want to sweep the house or sweep the hotel, that type of job only you can get from there. No matter even you're rich also in that countries, if you're planning for a part-time job, that's type of jobs only you can get. Then no sir, currently nowadays it is restricted for the people who are doing higher studies. Part-time jobs are restricted, but no any idea, try to manage something, she told like that. Okay. Now just suddenly I told that now lots of money you want to spend, right? Only the tuition fees 200 lakhs, right? But sometimes if you are breaking into small category money and if you are giving, it is somewhat affordable for some people also. You have a Scoville. I asked that how many students in Sri Lanka are going to this intake. There are two intakes, this February intake and July August intake. Right, February intake, how many students are going from Belarus from our country? All around 60 plus. 60 plus people going to the Belarus from our country. Likewise, worse scenario. If you have money, worse scenario. But I don't want to be like that. If you can go to Colombo, but the problem is that I ask one thing, then will you come back to the country? She said, sir, I have no intention of coming back to the country. After I graduated, I will migrate to UK or Australia. She don't like that only. Because even some students notice that the students who are doing abroad degrees, and when you come back to the country and when you are planning to work as a professional doctor, it's not easy. There is a kind of right, there are lots of stories behind, and you want to do some exams in Sri Lanka and you want to pass that, it's not easy. There are lots of stories. Just sit. Okay, next idea. Just sit, next idea. Right? Okay, done. Put some reply. All clear, 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 put some reply. Put some reply. All clear? Right, okay. Next story, starting 14. Starting 14, 10, 15. Maybe 10, starting 14 story. 14. 14. Starting 14. Starting 14. Starting 14. Keep on doing. Keep on doing. Keep on doing. Okay, last some minute time. Starting 14. Keep on doing. The 14 idea. 14 idea. Keep on doing. Starting 14. That story. Starting 14. Right. 14, 1 is missing. Now they have given point A, B, C, D. The other mass should be, put the other mass as here. The other mass must be, put it as point A is there, mass A is there. The next side mass must be, they should have given a value. That should be, put it as 10 kilogram something. Put it as 10 kilogram. Then 120, 10 kilogram, yeah. It is 10 kilogram, it's 10 kilogram. The system shown in the figure, the strings and rods are light and rods are horizontal. Draw the force diagram for the force equilibrium of each rod. Find the masses of ABC. Find the mass of ABC, find the tension in the strings XYZ. The last question maybe. Start doing that question. Question number 14, not difficult. Last question maybe for today. Right, 14, starting 14. For starting 14, the given diagram. Starting 14. 14. Starting 14. Starting 14. Keep on doing. 3 centimeter, 5 centimeter. Right, not difficult, seem like difficult, not difficult. 4 centimeter, 8 centimeter, this gap is 4 centimeter. This gap 4 centimeter. This gap is 8 centimeter. This gap is how much? This gap is 3 centimeter, 5 centimeter. This gap 3 centimeter. This gap going to be how much? 5 centimeter. Two centimeter, 6 centimeter. This gap 2 centimeter, very simple story, 2 centimeter. This gap going to be 6 centimeter, right? The masses. So they are asking us to find the mass of ABC. This mass simple A. Simple A. If we mark the simple A, this mass take it as 10 kilogram something. 10 kilogram something. Then this mass is B and that mass is going to be C. This mass B, equilibrium, all about equilibrium. Capital B mass and this one is capital C mass. Really simple story. Seem like very difficult. Diagram looks like very complex, but no big deal. Mark the forces. On 10 kilogram mass, if you properly mark the forces, see the way I'm marking. If I mark the 10 kilogram forces, weight is 100 Newton. Weight 100. Tension force on 10 kilogram is T1 upward. Always mark the tension force belongs to 10 kilogram, nearby 10 kilogram. T1. Then what is T1? Tension force acting on this rod. You can give a name for this rod. Let's give a name for this rod. This rod, the capital X something. This rod, capital X something. Now they have given X, Y, Z also. Okay. Right. Now they have given a name for the rods. Rod X, rod Y, rod Z. This is the rod Z. Rod Z. Capital T1 means what? Force acting on the rod Z. Okay. I want to find simple MA. If you mark the forces on simple MA, the weight is simple MAG. MA into G. G is what? 10 MA. The weight is mg. Mass is I don't know MA. G is 10 MA. The forces on tension force on object A is capital T2 upwards. T2 upwards. If you mark the tension force on the rod, capital T2 downwards. Downwards. Now consider, now they mentioned the rods are weightless rods. Therefore, then on the rod already there are two forces, T1 downwards, T2 downwards. Because of the string, tension force acting on rod Z is T3 upwards. T3 upwards. Tension force acting on this rod is T3 downwards. That's it. If you consider equilibrium, what's your T1? 10 kilograms equilibrium. Look here. Equilibrium of 10 kilogram. If you consider equilibrium of 10 kilogram, very simple. Equilibrium of 10 kilogram. I will show one part and do the remaining part as homework. 10 kilogram. What can you say about T1? T1 must be equal to 100. T1 must be equal to 100. T1 must be equal to 100. 100 Newton. Okay. Then likewise, that capital A mass is also under equilibrium. Then there are two forces acting on capital A mass, T2 upwards, 10 MA downwards. T2 must be equal to how much? 10 MA. If you consider equilibrium of capital MA mass, equilibrium, you can write down T2 must be equal to how much? 10 MA. T2 must be equal to 10 MA. Clear? 10 MA. I want to find simple MA. Now this rod Z is under equilibrium. This point is point capital. This point is point capital Z. They mentioned this point is point capital Z, I think. This point is point capital Z. And this rod is under equilibrium. You can take the torque around any point on the rod. Okay. If I do the rod, there are three forces. T1, T3, T2. If I do that story for your understanding, I give a name this rod simple A, rod simple A. If I wrote simply for your understanding, okay, you don't want to do the diagram and you don't want to get the answer. You don't need. Okay, I'm showing the story. Do the remaining stories at your home. The remaining stories. But please update your term test marks. If you are going school, update your term test marks. Even your mark is 0 also, be happy. You want to think that I am your kind of what? Shadow. When I tell the mark, sir will laugh at me. Why should I laugh at you? When you become sad, I am also sad, to be honestly. T1 is how much? T1 is this T1. Tension force acting the rod T1. That is 100. So when you become happy, I am also happy. As a teacher. Then T2 is how much? T2? T2 is equal to 10 MA. 10 MA. 10 MA. The other force acting on the rod is T3. I don't know T3. T3 I don't know. T3 I don't know. This point is point capital Z. But they have given this gap is 4 centimeter. This gap is how much? This gap is 8 centimeter. This rod is under equilibrium. Rod simple is under equilibrium. Resultant torque around any point on the rod is 0. If you take the torque around point capital Z, resultant torque is 0. There are three forces acting on the rod. 100, 10 MA and T3. If it is the torque around point capital Z, resultant torque around point capital Z must be 0. Then around point capital Z, 10 MA creates clockwise torque. Therefore, plus 10 simple MA, plus 10 simple MA, perpendicular distance to this force from this Z point, 8 centimeter. 100 creates anti-clockwise torque, minus 100 into 4 centimeter must be equal to 0. Simply clockwise torque equals anti-clockwise torque. That is the idea. Then get the answer. Then if you simplify it, finally, 80 simple MA. 80 simple MA must be equal to 80 simple MA must be equal to 400. 400. Finally, what is your simple MA? Simple MA going to be how much? That is going to be 400 over 80. 400 over 80 means how much? 5 kilograms. 5 kilograms is your simple MA. And now what is T3 then? Right, 5 and 50. 5 kilogram means this weight is how much? 50. 50 and 100 means upward force T3, downward force 100, downward force 50. What is T3? Upward force must be equal to downward forces. 100 plus 50, 150. Likewise, now this one's equilibrium. This one's equilibrium, you can do that story. Can do ni? Can a story, don't worry, I will discuss all the tutor questions. Right? This February month onwards, I will do lots of sessions, extra sessions. Right? And I am evaluating some students hereafter. I am 10 MA, how it came 10 MA, why? Mass is simple MA. Weight of this is what? Mg. Weight is Mg, mass into gravitational acceleration. G is 10. G is 10 means 10 MA. Mg, MA into 10. That means 10 MA. Put a reply, everything we learned today is crystal clear. Put a reply. Put a reply, everyone. Everything we learned today, crystal clear and sound. It's crystal clear and sound. Everything we learned today is crystal clear and sound. Crystal clear. Everything we learned today is crystal clear. Put a reply. Put a reply. 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 This week onwards, I will do lots of sessions. Right? I will plan lots of sessions. You work with me unconditionally. We can go for a good result. Reply, everyone. Reply, everyone. Reply, everyone. All clear. Put a reply. All clear. So all good. Everything is superb. Everything is very clear. Put a reply. Very clear. Put a reply. Very clear. Put a reply. Very clear reply. Right, okay. Okay, then lesson is finished. Listen to stories. Okay, right, okay. Stories, okay. Right? Come and write the target papers. Okay, hereafter, right, from next week onwards, I will keep a small track how many of you are following what I say. The homework is redo the stories once again. Today questions, if today only we had done the question. Today questions redo once again roughly. Today itself, because you can't postpone tomorrow, because when tomorrow comes, you have another set of works to be done tomorrow. Therefore, today itself plan something and do this question today itself homework. Next story is prepare a short note. Now we completed, I think, did I ask you to prepare a short note regarding work energy power? I can't remember. Can someone reply? Did I ask you to prepare a short note regarding work energy power? Reply someone. WhatsApp. Reply via WhatsApp. Did I ask you to prepare a short note regarding work energy power before? A short note. WhatsApp. 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 Reply someone. Did I ask you to prepare a short regarding work energy power stories? Nobody? Right, okay. Homework. Work energy power short note. Refer, first of all, before preparing a short note, refer everything. Read the theory once again. Then only you will prepare a short note. Then understand what is important. Try to reduce the words as much as possible. What is the core? Without this, we can't do anything. Those things include in a short note point book. Equations, okay. Some short equations, okay. Definition and all, you don't put in the short note point story. Definitions and all, not that much relevant. No need. Then work energy power, and then what? And then this what? And then this force equilibrium talk story short note. Work energy power one short note. Talk story and force equilibrium and the short note. And I have a small plan. Write this that planning book story short note point book. You will get the mechanics short note point book. You will get very soon. If it is possible, next week tute. Still, it's not printed. If it's not possible, along with the next tute, you will get the short note point book. That's okay. You don't specifically tell, yeah, specifically tell, but make short notes on distance. Okay, we cover everything, right? And also the day planner means kind of workbook, right? I will give a workbook. You want to mention how long you used every day, how you spend your time. 30 days, I will keep 30 pages. 30 pages you want to mention. People who work continuously, they don't require those things, but others also require any. Therefore, I'll send a workbook not now, very soon. Not now, very soon. Then workbook every day, how you spend, how you wasted, how you wasted, why you wasted, right? That type of detail idea is there in the planning book is coming very soon. And also that story, people who are properly, yeah, and also I have one plan that now it is target papers, monthly topper and right, who is leading. If it is possible, a graphical way, I am doing some stories, okay? Right, then target paper one, the topper is, for an example, X. But this Y is really 20 something out of everyone. But target paper 2, 20 came to second position. That kind of thing I'm planning, okay? I am not sure. That story is coming upcoming days, monthly topper. That story, then kind of video and telling and comparison. Then what is coming upcoming days? Then paper writing will be happening through the website. Paper submission, that story Ace Academy also they are doing, right? That will be happening very soon. Then you don't want to submit the paper via WhatsApp, right? I don't want to send the paper via the WhatsApp. Everything will be happening in the website, and you want to click the link, and that's what I told you in that story. And especially who are really committed, that much of commitment, I'm going to keep a set of students and I'm going to work with them separately. Separately means that does not mean I'm giving some additional work for them. By that NEET exams, Indian textbooks, NEET exam, GE exams, that is what they're asking here also. For the people who can bear the load and all, right? I'm doing lots of classes here, and people who are really curious and really working hard, who want to give this story eagerly, giving extra more and more load for them. I'm loading more stories for them. That's what happening there. Right? That story also coming, not very soon. Okay, don't expect tomorrow. No, can't. Right? That story is coming. Right? Okay. Okay. Study well. Don't worry. Don't fed up. I am there. I am there for you. Don't worry. Study well. That's it. Okay, I am there. Okay. We'll stop the class for today. Then study well. Next day we'll do the class via Zoom. Then good night. How many time I took for the exercises? Yo, very tired for me. Then see you.